Very good morning, everyone. Can you guys hear me? Let me know in the chat. Can you guys hear me and see me as well? Nobody is responding. It means you guys are not able. Okay. So thank you, Suraj, for confirming. Very good morning, Joseph. So very good morning, everyone. How you guys are doing? I see only 7 people has joined. Huh? Still people are sleeping. Huh? Oh, 3 minutes are there. Okay. So we will wait for next 3 minutes. So So yes, guys, so we have completed our sorting part. So we have completed, I think, 5 and 3, right? 8 sortings, algorithms. And after that, now the sorting part is fully done. Now we will jump into the next topic, which is very interesting. Linked list is very interesting topic, guys. So like, I think now whatever we are going to do further, those all going to be very interesting. I have doubt in the code of sex tuplets problem. So Joseph, we will be very soon having revision classes. Okay, in that revision class, we will look into those doubts. Okay, or we have shared that LinkedIn group, right? We have created that LinkedIn group. I think I have already sent it invites to some of the people, so you can post your queries there also. So whenever I will have some time, so I will look into that, or might be other people who are already in that group, so they can answer those queries. Okay, Joseph, so you can post that query there. In morning, if you guys have seen that group, I have shared one article there, very small article. Or no, it's not article, it's a blog. We can say very small blog or article, whatever you want to say. And that article is about like Bigo notation. How like very nicely with a good example they have explained about how can we think about time complexity, how can we think about space complexity, and how these Bigo notation and time complexity is relevant in whole computer science. Wherever we talk about computer science programming, everywhere this time complexity, space complexity, or Bigo notation, how much importance that play. So I would suggest to everyone to read that blog. And whoever has not joined yesterday's class, I think Ekta has not joined, Nilanjan also has not joined last class. So first I will request everyone, please join daily classes. If you guys will miss it, I think some of people have found yesterday's class interesting, might be because we have discussed very nicely, also explain the count sort, right, Ekta? So you were asking me in the LinkedIn chat, right, about that count sort first second approach. So we have discussed that second approach very nicely yesterday in our last class, and I told you why we should go with the second approach only. So you have to go and watch the recording now. But yeah, so guys, yes. So today I'm also seeing very less people. 11 people has only joined, and I only told to everyone in the last class that the linked list is very interesting, and you should all like join the first class. Otherwise, you guys will miss, right, the important concepts like the base which we will today discuss. So yeah, let's wait for 2 more minutes and let's see more people can join. Then we can start today's our interesting topic, linked list. And I will tell you like this personally, when I was like learning about data structure in college. So this was the first data structure which I was feeling like very confident while learning about it. Oh, very interesting also. Like before that, mostly people teach about arrays, then stack, queues, and after that they jump into the linked list. So I was not able to understand stack and queues very nicely. But most of the people I have heard, they found it stack and queues and array are easy, but linked list they found complicated. But opposite to that, I found linked list very easy compared to stack and queue, because in linked list everything, one line of code is also the visualization. And I like that part about the linked list. Like I'm trying to solve any problem on linked list. I directly create that linked list and then start thinking, start visualizing it. So that's why I personally find linked list very interesting, very easy. But yes, sometimes it becomes complicated as the problem arises. There would be some of the scenarios or use case where this linked list could be a little bit complicated. But yes, do not think about in that way. Start understanding the basic things, how the linked list work, why we are going to use the linked list. We'll talk about it, and then we will start learning linked list, implementing linked list. Okay. So let's see. Still 14 people has joined. Okay, we will talk 1 or 2 more minutes, and then we will jump into the linked list. So, so before that, I was telling. So okay, so you guys, in meanwhile, you guys can share. I have shared one blog right yesterday about the starting journey. There was one student, electronics student, who was starting journey in the programming. Did you guys find interesting, or anyone has like get any perspective from there, or any feedback for that blog, or you guys have not read it till now? I was thinking. Aradhya, while sleeping, you can read it, right? Before going to bed. I was okay. What about others? Anyone has not read it, or anyone has read it? That person can share the feedback, so other person can find it interesting. That's okay. That's okay. No problem. No problem. That happens. So nobody has read it, huh? That's fine. That's fine. Okay, so yeah. I can see. Nobody has read it today. Yeah, so please read it. I have provided now. If you will go into that group, I have provided 2 blocks. Try to complete it. Those 2 blocks which I provided, try to read it, and then leave the comments also, so other people can also find it interesting. Some people, they just did not read it till people write it. It is interesting. You have to go and watch it. Some people didn't read it. Some people only read it when they read these type of comments and reactions and feedback. So that's why I will tell you, you guys share your feedback there, so other people can interested, other people can read it. Oh, so I think Hari Haran is joining today's class, huh? He has not joined yesterday's class. Hari Haran, you have joined yesterday's class? Okay, he has just joined it, so he would be responding in some time. Yeah, he didn't, I guess. Yeah. Okay, so I think we will not waste more time. We already spent 5 minutes, so let's jump into our today's topic. Okay, guys, should we, or should we wait for 1 or more minute? Oh, very good morning, Nilanjan. So I was missing you yesterday, and you are joining today. I was not expecting you are going to join today because it's Saturday. You have to go for office, right? Oh, okay, great, great. So yes, I think yes, you have taken leave on the right time because we are going to start a new and interesting topic, linked list. So so actually people are joining it. So I will again share everyone that very good morning, Hariharan. So that I have shared 2 blogs in the LinkedIn group, which I have shared. I want everyone to read about these things and then share the feedback. Okay. So did you ask me something? Now next. No. I didn't ask you, Joseph, anything. Okay. So I think yeah. Now we can start, guys. I think Deepak. I'm sure Deepak has joined or not. But let's see. Let's start today's session, and then people will join in the middle. Then we will talk about it. Okay. I've already created some points, which I'm going to discuss it, and then we will later on we will start jumping into our implementation part. Okay. So first, let me know you guys can hear me clearly or not. Then we will start our topic. Clear, right? Okay. Okay, so let's see. Everyone knows. Oh, Vishal is there. Very nice. Vishal is also there. Ankit is joined or not? Oh, great. Nice, nice. So everyone is here. So let's see. So see, guys, if we talk about around us, so we will see that the one thing which is all around us in this new software era, which is information, right? Information or data, which is all around us, right? And like if you talk about the any of the businesses or any of the payment transactions, any of the things right now, I think we have already discussed earlier also when we're talking about the APIs. At that time also we talk about the how the data is relevant, right? How much data and information they have started telling that the data is a new currency, right? Or information is a new currency. Everyone agrees with that. So for that, when we talk about that much data, like informations and that much information, so we should have some tools. We should have some tools so we can easily store these data and efficiently. We can store this data efficiently. Why we are doing that? So we can easily manage them, or also if we want to retrieve, so if we have trillions of data or billions of data, and if we want to retrieve some of the patterns out of that, so we should be easily doing that. We should be easily doing that. So that's why there are a lot of tools available, to organize these data, or providing you a way to easily like retrieve some hidden information from the data. Correct. So what I'm trying to tell you here, that the part of data structure, how it how much importance this part of data structure plays in right now in our industries, because everywhere we are surrounded with data. And for handling this lot amount of data, or we can do easily operations on those of on this much ton of data, we need a way, we need a tools, so we can easily organize this data, and efficiently we can do the operations on top of them, right guys? So that's why the data structures comes into the picture. That's why even you are talking about any languages, Python, Ruby, C++, C, JavaScript, everywhere data structure plays very important role. And reason for that is only the information, because information is a new currency, and for storing and for easily interacting with this data, we need an efficient way to interact with this data or store this data. Okay, guys, are we clear with that? Why the data structure is required here? Are we clear with that? Yes. So now let's see, if we talk about any of languages, if we talk about simply a JavaScript. So for storing any data, what we generally use, if we talk about JavaScript, till now you will see that for storing any of the data, we use variables, right? We use variables. Sometimes we use arrays. Sometimes we use objects, right? Most of the time we have worked with only these three of the we can say the storage bucket. We can say them as a bucket. In the variable, sometimes we are putting data. In array, sometimes we are putting data, and in objects we are putting, sometimes we are putting data, right guys? So every language provides these type of data structures to us, in which we can easily store our data, and then later on easily interact with them. See, in array, first we store the data, then we interact with them. In object, first we store the data, then we interact with them, right guys? So in similar way, there are like multiple data structures are available. Not only these three. If you go in the if you go at the root level, there are many data structures available. And we, like, till now we have only interacted with arrays, because arrays were the we were trying to store some of the data directly. We can store in arrays, right? But there are multiple data structures available for us, where we can store information in different way. They provide a different strategies, right? In similar way, there is one data structure which we are going to talk about, that is linked list. That is linked list. Similar way as other data structures are there, in the one of them between all of them, one of them in every data structure is linked list also. Okay, guys. So before moving, before jumping more into the linked list, let's understand two more things. What is linear data structure? What is non-linear data structure? Okay, guys. What is linear data structure? What is non-linear data structure? Anyone wants to explain about what is linear data structure? If you guys are aware of linear data structure, anyone wants to think about what would be the linear data structure? Let me see if I'm not missing anything. Yeah, I'm going good. Data is stored in a sequential manner. Vishal is saying linear means only in a one dimension, no subparts. Okay. Data is stored in sequence like arrays, sequentially arranged data like array stack. That's totally right. That's totally right. When we store our data in one direction, when we store our data in one direction, right? You guys know, if you guys know remember about one game, mostly I think in childhood we play, what we do in our floor, we just create one square, like multiple squares, and in those squares we write numbers like 4, 5, 6. Let me show you. Let me share my screen. You guys can see my screen. Yeah, this one. Let me open it into the new screen. Open image in new tab. You remember this game where we start from the first index, from the this first place, and then we have to go to the end, which is 10 here, and we have to touch like every numbers here, right? You remember this game? I know some of you have already played it also, right? It's a very interesting game. So this is yes, yes. So this is, you can see the numbers are linearly arranged. They are in the sorted order. They are in the linearly arranged. They are sequential. If you want to go to end, you have to go. You have to traverse each of the place. Whatever, like multiple places are there, right? First is the one place, then 2, 3 is there, 4, 5, 6, then 7, then 8, 9, 10. So agar tumhe, you have to reach to the end, you have to go through each of the element, then only you can reach to the end, right? So it is just running in one direction. That's what the linear data structure is about. Okay. And when we are not traversing like this, then we say that those all data structures come into the non-linear data structure. So whoever is not traversing like this, like one after another, then those are all the non-linear data structures. Like if we take the example of trees. If we take the example of tree, so in the tree, how things happen. In the tree, like this is our root. From the root, we can go in any direction. There could be 3 routes. If you want to reach to the end, there could be many ways, right? If I'm saying this is my end, this is my end. So like for reaching to this end, there could be many ways. So this tree, generally this tree, graph, these are also data structures. You can see we are storing data in this way also, right? These all come generally in the non-linear data structure. Non-linear data structure. Okay, guys? These are the non-linear data structure. So now talk about the linear data structure. Why I talked about the linear data structure? Because linked list is also linear data structure. Linked list is also linear data structure. So everyone remember this thing. I started with telling you the importance of data structure with the example of information. That information is all around us. Then we need a way we store and efficiently do the operations on them. That's why we use data structure. After that, once we know about the data structure, I showed you some of the examples of data structures like array, variables, and objects. These are some of the examples which you guys have used for interacting. Then we jump into the Then I told you there are like them variables and of arrays and objects. I told them there are many other data structures are also there, and one of them is linked list is also there, like trees and graph is also there, right? Then I told you about this. Then we jump into the linear data structure, like different type of data structure, and then we talked about linear data structure, non-linear data structure. I have showed you the example of like the real life example of linear data structure, and I have showed you the example of non-linear data structure. Then I told you linked list is a linear data structure, is a linear data structure, and array is also linear data structure, because in array we also go into the one direction. In if you talk about the array, in the array you guys already aware of, whenever we insert any element, we go through the indexes, correct? So array and linked list both are linear data structure, both are linear data structure, linear data structure, because we move in only one direction, we move only in one direction, correct? So array also non-linear, no, array is a linear. Also 2D array is linear too, right? 2D array, yes, it's also linear. You can see at one time we can traverse at one direction, in this direction, or at this place, or at the bottom direction, right? It based on the index. If we talk about the simple array, it's always the like what do you say, linear data structure. In we only in at what time, and one time we can only traverse at one place, correct? We can look for that also, that 2D comes into the linear or not, but I believe 2D comes into the linear data structure only. Okay. Okay, guys. So now we understood linear data structure and non-linear data structure. But still, you guys can say, like if there is already array available for us, why we will go for linked list, right, guys? You guys can think about, if array is already available, which is linear data structure, why we will go for linked list, right? So see, guys, the reason for going for the linked list is based on the memory allocation. It goes to the very basic level, which is memory allocation. See, the reason for choosing array and like difference between arrays and linked list, it mostly reside on the first difference, which resides on the base level, which is the memory allocation, which is the memory allocation. So let me show you how, whenever we create any arrays, how at the operating system level, how the memory assigns to arrays and how the memory assigns to linked list. Okay, let me show you that quickly. I'm not talking about the dynamic languages. I'm not talking about the dynamic languages like JavaScript, Python, Ruby. These are dynamic languages. So they already take care of memory allocation. So that's why we are not right now talking about the JavaScript and Python, because they have already lot of abstraction there. While we are creating any array, they already have a lot of abstractions, so they already optimize it in this way, so we can use arrays in everywhere. But if we talk about the C or C++, which are very basic language, which are static languages, not dynamic languages, so there we will see how the memory for array allocated. Okay, not talking about the dynamic languages. Dynamic languages like JavaScript is dynamic language. It assigns memories at the runtime. You never tell to the, you remember, when we create array, we just put empty square bracket. We never tell that what is the memory we are allocating to array. We are not telling that. This is all abstracted for us. Abstracted means we do not, like, whatever the things system already take care of, those things are abstracted to us. Okay, but let's talk about the array memory allocation for the static languages like C or C++. For those type of languages which ask you to assign memory, like Java also, which ask you how much space you need. Okay, so let's see, if we have like 7 letters, if we say like reliable, RELVEL, it's 6 letter, right? And if you want to store all these 6 letter in one array like this, R, E, just giving an example, guys. Just take, just giving you an example. V and E and L like this, and I'm saying all of this one digit is going to take 1 bytes, right? In the operating systems, we store things in the bytes and bits, right? 0 1 in the 0 1, right? So let's see if I have memory. So I will tell you how this 7 bytes will be allocated. And if I say these are, okay, 1 minute. I'm not that much good in drawing, so please bear with me. I will try to do my max. So if we say this is our memory, like this, we can say we increase little bit more memory. Not like that. Yeah. Let me draw it quickly. So if we say this is our memory internally, and this each block is 1 byte. This each block is 1 byte. So for array, in the case of array of 6 size, you know how this will be allocated in the memory level. All the 6 memory contiguous. So 1, 2, 3, 4, 5, 6. All the 6 blocks will be assigned to this array. All the 6. Let me choose another color. Yeah. Let me. Yeah. All these 6 block will be assigned to array. Understood, guys? All this 6 block at a same place. It's not like that. At a same place, they will be allocated to array. That's how the memory allocated to the, because you know in the Java we say like this, array 6. When we create a new array in Java or in C++, we say like this is our integer array, and take the 6 places of that. So it will be allocated like this. So you can see in the case of, and you know, in the linked list, how this happen. If this is the same memory space for linked list, I will tell you how the difference arises. If the same memory, and if we are not using array, if we are using linked list strategy, you know, in linked list, if we have to assign these 6 values, we do not need to assign it as a continuous memory. We can assign one block here, we can assign another 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 block here. So that's why that's where the first difference, this is for array and this is for linked list. That is the first difference which occurs between the linked list and the array. Okay, that's the first difference which lies for linked list and array. Understood, guys? That's how we take the same here. In the continuous memory, so space not based. Yes, no. So reason is that, see, guys, first thing, you have to take all this memory, all this block at a contiguous place. So if you see only if there is like something is already running in memory, like you see, if something is already running in all the blocks of these memories, if something is running in all these blocks in memory, like you have 4 GB RAM and everything is filled here, right? Everything is filled here. Everything is filled. Only you left four blocks. So now you cannot assign memory to array. Now you cannot start the operation because this array needs 6 spaces. That also contiguous. So now you can see these all 4 spaces. You cannot initialize the array. But in the linked list, you can. In linked list, first block will come here, second block can come here, third block can come here, fourth block can come here. Right? For linked list, this particular part is fine. So that's what. So the first difference is, guys, while we are generating any array, we have to decide the space. We have to decide the space for that. And second thing, guys, if we want to increase, like right now it's 6, but after working some time, if the size is increased to 7, we cannot easily add a new space in the array. That's the second problem with array. We cannot add a new space for that array. For that, what we need to do, we have to create a new space now. We have to create a new space for 7 elements like this. And then we need to copy all the elements from here. That is another problem with array. But in the case of linked list, all the elements are separated. All the elements are separated. So we can easily add the 7th element. Right? If we want to, like, if I'm talking about the increasing, if you want to reduce the size, we also have to do the same thing. Right now it's 6. If you want to do 5th, we only want 5. Again, we need to create a 5 spaces. We need to copy all those 5 elements in the array. But in the case of linked list, we can simply delete it. We can simply delete this element, and then then we can easily do the linked list here. But in the case of array, these are very difficult operations. Okay. Understood, guys? So let's see some of the questions which you guys have. First, tell me, did you guys understood this thing? How the memory allocated in the arrays and the linked list, how they are, like if any node is coming, how they are separating it or putting it into the memory. Okay. But this does not work in the dynamic memories, like dynamic programming language. They are already taking care of these things. Let's see now the questions. Okay, so how the memory allocated for 2D array? So 2D array, see, look it, for the 2D array, in the similar place, we'll take this much. Okay, let's take another example. In the 2D array, the memory space will not be horizontally. We'll also take the vertically. You see, this is now 2D array in the memory. Now this 2D array is fixed. Understood, Likit? Right? Now let's see next question. So space not wasted in linked list. Yes, that's right. Space not wasted in linked list. Like जितने भी elements आ रहे हैं, हमें उतना ही space create करना है. How many elements we got? Only for those elements we will create a space. If there is any new element is coming, we'll take a new space from memory. That's totally right. Vishal has put it correctly. Not continuous in linked list. Not continuous in linked list. I didn't understand this meaning. This does not look sequential, sir, for linked list. No. Okay. I'm not saying the memory assigned is sequential. I'm saying traversing is sequential. Guys, there is difference. Joseph and Hariharan, if you are asking the same question, so let me tell you, I am talking about traversing, like traversing or visiting those nodes. Visiting those nodes are sequential in both places, not the memory allocation. I am not saying the memory allocation is sequential. Traversing means, like if there is a 2, 4, 5, 6, 7, so first I will traverse 2, then I will traverse 4, then I will traverse 5, then I will traverse 6, then I will traverse 7. That is traversing or visiting. In both places, in array and linked list, we traverse like this only. That is sequential. I'm not talking about the memory allocation. This I will tell you, this because in the array you can easily, acha, okay, you got the confusion. That's very good confusion actually. Okay, so see guys, you got the confusion because you see the structure, it is continuous in the memory. That's why you saw it like, okay, in the array, that's why we are able to traverse it like continuously, because in the memory. But this doesn't depend on the memory at all. This depends on how you create your nodes. This traversing part depends on how you create your nodes, guys. Right now you are creating a nodes in this way that it will easily traverse the next one. That's why in array traversing is very easy, because we know the indexes. We know that at the one index this second element will be there. That's why in array traversing is always easy. In linked list traversing is not that much easy. So I think we have also covered the disadvantage. Disadvantage of linked list is also there, guys. With this point only, traversing is not easy. Traversing is not easy. It takes extra time. It takes extra time compared to array. compared to array because of this memory allocation. क्योंकि in array we have allocated all the spaces at one place, so we can easily traverse. We know that after, if there is second element we need to find, we know that it will come at the one index. We already know that because we know that that's how we are storing these data. But in this place, in linked list, we do not know where the next element is, so we need to find that next element. But yes, again, answering to your question, traversing is going to be sequential in both scenarios. But now I told you one more point, traversing is not easy because we do not know where the next space is, and which is not like, we know where the next space is, but that next space is not just like the in the contiguous, that next space is not going to be contiguous. That's why the traversing is little bit different. But insertion and deletion, insertion and deletion is very easy in linked list, very easy in linked list. It's costlier in array. I showed you, right? If you want to insert or delete it here, you need to create a new space, then you can insert the things. Same goes for deletion also. But in linked list, anywhere you can insert the new element. Right, guys? Does it answer your question? The sequential part? Let's see. Likit is saying, Hariharan, we can connect all nodes sequentially after making nodes. No, yes, that's right. But Hariharan, just understanding the traversing part, sequentially part depends on nodes, not on memory. Depends on node. How you are trying to generate your nodes, how you are trying to put your element. I will show you with the example also. Arad is saying for nodes, we do not need to assign memories. For nodes, we don't need to assign memories. Why not? Why not, Arad? These are the nodes, right? We are trying to assign the memory only to those nodes. So there is flexibility in linked list. Unlike, yes, the flexibility for insertion and deletion. Joseph, for flexibility for insertion and deletion. So nodes, okay, for linked list, we don't need to assign. For linked list, we don't need to assign memory. Oh, for linked list, you mean we do not need to assign memory. I mean, how the address are given to them, like array 3, array 4, if first element ID is 1000. I mean, how the address are given to them, like array 3, array 4 address. It first ID at 1000 and first element ID is 1000. I think traversing linked list is same as array. I didn't understand you this question part. I mean, how the address are given to them, like array 3, 4 address. Its first element is ID 1000. So see, I think if we are talking about array 3, 4, and if you're talking about the address for that, so we can simply create. So I think in similar way, like, so the traversing will happen here for, this would be 3, 4 somewhere, would be 3, 4 would be 3, 4 would be here somewhere. So this would be your element, right? And address would be 1000 or whatever address is there for this particular block. You need to traverse it, right? 3, 4 is a traversing. You need to do the traverse and reach here to this particular block, and that would be, for that block address would be 1000. Okay, Likit? For that block address would be 1000. Array is like running on rails. Running on rails. Okay. I think traversing in linked list is same as array. ON. No, actually, in the array you can like if you want to fetch the fifth element, you can easily fetch it, array 5. But in linked list there is no way like that. It will take constant time in array. If you want to fetch any of the element from the places like array 5, you can simply take that particular block and you will get the memory. But in linked list you cannot do that. You have to start from starting, then you can only go for the fifth element. Okay. Likit, okay. Likit is saying, yes, how to find that address? If base address is 1000, base address is starting address of array. Yes, that would be the starting address of array. Then you will start 1000. See, the array 0 0, it will start from here. So it would be 1000. This would be 1001. This would be 1002. This where is the array? Yeah, this is 1000, 1001. This would be 1002. This would be 1003. Then there would be something else. Then there would be 1004. Then it would be 1005. Then it would be 1006. Then it would be 1006. These are the memory. For 3 4, address would be 1006. The traversing will happen like this. First you will traverse 3 times here, then 4 times here. Sorry, 3 times this side and 4 times this time. Then you will reach to this block, and then you will find the address for that. Okay. So Ekta is saying fetching individual element is time taking in linked list. Yes, no index based access. That's right. That's totally kept it properly. No index based access in linked list. Correct. Predefined path. I meant by running on Rails. Yeah, like indexes. That's right. Yeah. Understood. This is row major order. Row major order. Yeah. So we can say like row and column. Yes, we will traverse in that way for the 2D arrays. Let me see if I am missing anything before jumping into the next thing. I already told you about what is the difference between. Yes. So now let's jump into the next part, and let's see how these memories are scattered in different way, and still we are able to traverse it. Somebody was asking, right? This would not look like contiguous. So now we will see that thing. Key in linked list, how these elements are scattered, and still we are saying that it is contiguous. Still we have to maintain the continuous part. So for that, now we have to understand how linked list looks like. What are the basic parts of linked list? Okay, so let's jump into that to understand what is the basic parts of linked list. Okay, guys. So in linked list, there are some of the parts which everyone has to remember. Everyone has to remember. Okay, the first part is start, from where your list is starting. What is the first element and what is the end element? You remember the game I showed you? In this game, you know that where the girl is standing, that is the starting position. And you have to know what is the ending position. That is the 10 element, right? The element number 10. So that similar way in linked list also, you have to know first what is the start element, from where we have to start the linked list, and where the linked list is ending. Two things, start and end. And third thing is node, where we are going to keep the data. The third thing is node. Okay, so first thing is start, second thing is end, third thing is node. And node has two things. Node has two things, which is the value and address of next node. That is what, guys, that is what tells to the linked list that you can be scattered. All the elements could be scattered. In the similar example, if we have this memory, the bigger memory, so I was telling you, right? Everything goes with the how you are creating your elements. So you can see if we have first node at this place, so it has two things. First thing is own value, whatever data we are saving, and second thing, it is keeping address of next node. So wherever the next node is, like this is node 1, this is node 2. So this particular node will keep the address of this node 2. So we can easily traverse to this node with the help of address of next node. Understood, guys? That's why the memory is here scattered. We do not need to create a contiguous memory here like array, because in the node where we are storing the information, in array we see, in the case of array we just store the element value like 1 or 2, but in the case of linked list, with the value we also store the address of next node. Everyone understood these three things about the linked list? First thing, you should be known the start or head. Some people also say that as a head, like it would be starting point, and this would be the ending point, and then it would be node. Correct, guys? Everyone should be knowing this. Okay, so now see how this linked list looks like. If we simply wants to let's just visualize it like if we have some elements 4, 5, 6, 7, right? If you want to create a linked list, or if you want to store these values in linked list, how this will look like? So first we'll create a first node. First we'll create the first node. So first node would be 4, and this node will have two things. One, own value, this part own value. Then it will have the address of next node. So I'm just creating an arrow for the address part. This would be the next address for the node. And then there would be second element, second node, and we'll say this as a node. Where we have both of the things, we will say this as a node. So now there will be second element 5. It will keep the address of element of 6, and then we will have the 7. Correct? So now you can see these all are connected. Let's keep this arrow outside. It will look better. Let's keep this arrow outside. So now you can see these all nodes are connected. How they are connected? Address of 5. It will write like address of 5. It will be address of 6. This would be address of 7. And after that there is no element, so we'll say that this is null. And this is only end. Whenever we find it out, that the address of any of the node is null, we say that our linked list is ending here. Or we also say that tail. This is the tail of our linked list. Tail means the last element of our linked list. And guys, here we have our start also. Start, and sometimes we say that head. So you can see in linked list, we take two variables, start or end, which tells us from where our linked list is starting, where our linked list is ending, and then we have our nodes here. These all of nodes are the linked list. So you can see linked list. It means a list which is internally linked. The meaning of linked list, a list which is internally linked. And you can see how these list or elements are internally linked with the help of address. Understood, guys? Now let me know in the chat, did you understood and visualize it? Because see, visualization is very important. And you know, guys, this nodes, this part of node is super powerful and super important to understand. Everyone, this part of node value and address of next node, this part is super important, because you have to always keep it in your mind how a node is created and what is the purpose of that node. Because in the node we always have two things, the value and then the address of next node, because with the help of this address only we are going to traverse it. Understood, guys? Understood, everyone? I think generator in JS also use same kind of approach. Generators, if I remember that part, right, where we were doing async iteration. So rather than synchronized iteration, we'll do the async iteration. That is generators, I remember, right? So Joseph is asking what head contains. Joseph, you think about what would be the head would be containing here, head or start. It would be containing the starting position. It would be containing the starting position. So starting position would be this node. Starting position would be this node. And in the same way, tail would be containing the last position of this array. So we can say in start, whenever we will print it out or console it out start, we will get the first element, which would be 4 and address. With the address, that's what we will be getting it. Understood? Address of a address of first node, I would say it is just like assigning. You are just assigning that whole node to the start, not only the address. See, whenever we are saying the whenever we are saying like assigning and pointing out, so it means it is just containing the whole node. It is, see, okay, let me clear that thing also. Now you are getting confused with the address and value also. I understood. So guys, when I'm saying, when we are like pointing out, when we are pointing out, it means this particular node already been created. This particular node already been created. So we are like, uh, if you see simply, if we take example, let a is equal to 5, correct? So a memory में created है, a is equal to 5. Now if we do let b is equal to a, so now you can see b is also pointing out to a. Now if I say let c is equal to a, so now you can see c is also pointing out to that. So that means if we will do console of C, we will also get the same result. If we console out the B, we'll also get the same result. If we console out the A, we'll also get the same result. In similar way, start is pointing out to the first node. First node. So when we will print the start, we will be getting the first node only. Okay. So yes, in one way, it is just keeping the address. If you want to go like downside in the memory level, so start is keeping the address. In similar way, a is keeping the address, b is keeping the address of a. So like there would be one variable b which would be keeping the address of a, like that, which would be like, this is pointer wise. In the pointer we keep address like that, and then whenever we want to access the b, it will be going to the a and then fetch the value from there. In the memory level it works like that, but let's not go in that much deep at the memory level. Just understand in the similar simple language, that is pointing out. Pointing out means if we want to console the start, it will print the same value of the first node of our array. So just remember like that. If you want to print anywhere start, if we have to start traversing our node, always we will be taking the start variable there. We'll start from the first one, and then if you want to end it, then at the end that would be the last node. That would be the end or tail variable. In similar simple language, do not make it very complicated on the address wise on that one. Okay, just try to visualize it and easily understand. So if somehow you want to start any linked list, if you want to start any linked list, you have to look for the start variable. If you want to look for the end element, you have to look for the this dot tail or tail variable or end variable. Okay, so that's how you have to understand the linked list. Okay guys, so now let's see one more thing. Let me see if I am missing anything before telling anything. So I already explained you why we do not need the continuous memory in the linked list, because we can see that the problems are continuous memories, and then we saw like how the linked list is helping us. We can create scattered nodes with the good designs of our nodes. How easily we are trying to how efficiently we are trying to create our nodes, and we can simply go to any of other nodes. Okay, so now guys, there are different type of linked lists available for us. There are different type of linked lists available for us. For the first one is single linked list, which is very easy one, which just runs into one direction, runs in one direction. Okay, अब ये linked list कैसी दिखेगी? It is same like the earlier one, like 4. This is the address 5, then the 6, then the 7, right? And there will be one more space, sorry, in between them, which would be the keeping the address of next. So I'm just writing n, or let's better, this would be null. This would be keeping the address of 7. This would be keeping the address of 6. This would be keeping the address of 5. And then we will having a start here, and here we will having the end or tail. Anything we can say. Head, tail, start, end. Understood guys? This is our single linked list. Very easy. It will always traverse in one direction. So first we will start from start, and then we will, if we have to find the 6, that the 6 exists in this linked list or not, we have to start from this part, start, then we will move one by one to 6 here. Understood? Everyone, single linked list understood? There is one more linked list, guys. That's called double linked list. Doubly or double linked list. You know, in this linked list, it could traverse in both direction, in reverse also, because now the element has two addresses. Element 4 will have two addresses, previous nodes and next node. Both of addresses will be here. Like if there is a fifth element, so it will have the address of 4 also. So address of 4, and it will have the address of 6 also. Now you can see how the linked list is little like slowly becoming little bit complicated, but also advanced. Now we can say 6, so it will have the previous of 5 and next of 7, address of 7 here, and then this similar way 7 will also be there. It will have the at the next it will have null, because here it is going to be end, and here it will have the previous of 6 or the previous address of 6, and here our start will be moving here, and this previous will be pointing out to null, because this from the start we are starting, right? Because this is the first node in our linked list, that's why there will not be any previous for this node. So that's how, guys, we create the doubly linked list. Doubly linked list means I am again telling you guys, in linked list, three things are very important: start, end, and node. You see, for doubly linked list, we have changed the node. And I told you earlier also, the node is very super important part, because whatever operations we are going to do, everything is going to happen with nodes only. Start and tail or head and tail, they will only help us in traversing. But the real operation or real changes which we are going to do, we are going to do in the nodes only. Did we understood, guys, the doubly linked list? Did we understood the doubly linked list, guys? Everyone? There is one more linked list, which is called circular linked list. Circular linked list means the end. Now the end, like if we talk about this circular linked list could be singly as well as doubly, both could be circular. So now if we say about the 4, so guys, now I'm just simply writing like this, one element, and this would be the next. This arrow, whenever I'm referring, it is just next element. Okay, this is the 5, this is the 6, and this is 7. In single linked list, this 7 will be pointing out to null, and this would be our start. This is single linked list. Correct, guys? But in the case of circular, if we want to make this linked list circular linked list, we just need to point this 7 to the first element. This 7 to first element. This will look like this: 4, 5, then 6, then 7, and then this 7 will point out to 4. So now the end element and the start element, they will both point to same place. That's what the circular linked list is, guys. Like start and end element will point to same place. Start and end. Earlier it was pointing out to null, right? After the 7 is pointing out to null, but now this 7 will point out to 4. So now we can just traverse it circularly, right? That's how the circular linked list works, and we will see with code also how we were going to implement this thing. But did you guys understood what is the meaning of circular linked list? The last element of the linked list this time will not point out to null, it will point out to start element. Everyone understood single linked list, double linked list, and circular linked list? So no, yeah, we will move into the code. Yes, last element will point to start. Yes. Yeah, you can see, Nilanjan. This is our linked list, single linked list. You can see we start from here 4, then we move into the fifth. The 4 is pointing out to fifth, fifth is pointing out to 6, 6 is pointing out to 7. Now 7 is pointing out to null. This is single linked list. But if this 7 is pointing out to first element, then this will become circular single linked list. This will become circular single linked list. Understood, Nilanjan? Yeah. So now, where is that? Vishal. Vishal is asking, why do we need AND? Why do we need AND, Vishal? Come back to this question. You see, we should be knowing, right, where to stop. We should be knowing where to stop. So we should be knowing where to stop. That's why we need the end or tail, where we can easily say that the here our linked list is going to stop. But we have node. Yes, we have node. So we have 5 node. So now we want to know which is the last node. In the 5 nodes, those 5, see Vishal, you see, this is our memory, right? One node is here, second node is here, third node is here, fourth node is here, fifth node is here. How we will know which node is start, from which node we have to start, or from which node where to end? From which node to start and then which node we have to end? Because this is not the array, right, which has the contiguous memory. So we know that the last, like the total length of array would be the last element. In array, we know that the length of array would be the last element. But in linked list, we do not have continuous memory. So we should have the places where we could find which is the start, which is the end. Understood, Vishal? Ankit, I will just look into your question. I will just continue the discussion with Vishal, then I will look into your question. So first node will address of second one, yes. Second node will have the second one have address of third one, yes. And then third one have the address of fourth one. Then and the fourth one, if the fourth one is the last one, fourth one will have the null. Fourth one will have the null. It means that's the end. It means that is the end. That's the end node. Understood, Vishal? The first node will have the address of second node. Second node will have the address of third node. And third node will have the address of fourth node. So now fourth element has been inserted. Now there is no new element. So what we will do? We will make the fourth element, the next of fourth element to null. So it means this is the last element. We have to tell to our linked list, right, where to stop traversing. So in the last element, we will keep the null there. Understood, Vishal? Yeah. So that's how you can easily identify which is your start, which is your end, which is your head, which is your tail. Okay, now let's take the Ankit question. Or I think before that, I think Joseph question is also there. Sorry, let me take the Joseph question first. In doubly linked list, as first node previous address is null. And doubly linked list is first node. Yes, because the first node will not have any previous. In doubly linked list, this first node will not have any previous node. So that's why the address for previous is null. It will not have any further nodes. Understood, Joseph? Let me know in the chat, Joseph. Did you understood? It has a start. Okay, Joseph. Start is pointing out to the first node. Okay, so this is our linked list. Doubly linked list. This is 4. This is next element, next address of 3. Start is pointing out to this. Again, start is pointing out. Start and this first node is same. Start and first node is same. I think you guys are confused with start. So let me think about some other way to explain you about the start and first node. Let me think about it. What could be the better way to explain this thing? Okay, so start and end, they are not nodes. First thing, they are not nodes. Okay. Okay, Joseph, just try to understand. Start, it's like a flag. It's like a variable. It's like a variable, right? And end is also a variable. It's also a variable. which is telling us the purpose of these two variables are different. This is the purpose of this start variable is tell me which is the first node in linked list, which is the first node in linked list, first node in linked list. This is not node, and the purpose of and is tell me which is the last node, which is the last node in linked list. Okay, I'm trying to explain it again, guys. I think some people are confused with start and end, and node is different. Node is different. Node is going to keep data and address. One node is going to keep, like in the, if you talk about the double linked list, node is going to keep 3 datas. Okay, one node is going to have 3 data, right? Start is not node. Start is not node. And now see, I explained you start and end. Now I'm explaining what is node. Node is going to keep some data. So node, there could be, if you talk about double linked list, so first data would be value. This would be the value. Then the second value is this node will have previous address. Then the next would be next value. So now this previous will have the address of node, address of node, address of previous node, and this part of this node will have the next node addresses. Okay, so these two places, previous and next, they are keeping the address of next of previous node. Okay, they are keeping the address of next and previous node and with the value, with their own value. Okay, so see guys, each node will have some properties. Okay, understood guys? Let's see, everyone, let's understood this thing again. Each node will have some properties. So first property is previous, second property is next, third property is value. So whenever we will create a node, all node will have these properties. This is not our start. Start is the start is a variable or a flag which is telling us which is our first node in all of them. So like if there are 5 nodes, 4, 5, 6, 7, 8, if these are 5 nodes which will have all the properties like this, previous, next, well, right? So now start will tell us which is the first node in all of them. 6 could also be first node, right? Or 4 could be the end node. So start and end are the like you know, the torch, or like I'm not getting the better words. So it's like a flag which is telling us the positions from where which in all of these 5 nodes, which is the start point, which is the end point. Okay, I hope you guys have understood now. Yeah, it's like a pointer. If you want to go a little bit technical, so yeah, it's like a pointer. It's like a pointer which tells us from where you have to start and from where you have to end. Okay. Let me now take the next questions. How do we find head and tail in circular linked list? So head and tail, I think, will be pointing out to same place, same node. Head and tail will be pointing out to same node. So we can say, we can check the values. Like if the head values and tail values is same, then we can say that this is a circular linked list. Okay, Ankit? And we'll see the circular linked list scenarios. Circular list has the head address of first node. Circular list have head address of first node. Okay. We can find tail if we encounter address equal to address of first node, then that is tail. Yeah, with that address also or with the values. Yeah. Okay. Okay, guys. So let's try to generate the node only. So let's start with single linked list, guys. So let me know. Did you guys get it interesting? Whatever we talk about linked list, what was it interesting? Or was it tough? How you guys feel it? Whatever we talked about till now, because now we are going to jump into the implementation part. You guys tell me, what do you guys feel till now? So Nilanjan, whatever part is looking too tough to you, just just ask the question there. If you will not ask, I will not try to explain more. Joseph has asked, I tried to explain him. Okay, whatever part looks like tough to you, you just ask the questions there. Yes, I think for others it looks interesting. So let's move into the next part, guys. So let's first, for the single link list, let's look into our single link list. Single link list. Okay. So let's see how can we create the node, because node is very important part, right? So for the node in single link list, it will have only two properties, value and next, right guys? For single link list, each node will have only two properties. So like if we want to create any node, like if you want to create four, like if we have three elements in three elements has been given to us. If you want to create the node of these elements, so they will look like this, four, and they will have the next. Then this is the first node, node one. Then we will have node two, which will be having five, which will be having next. And by default, I think we can say this all next will have null by default. When first time we are creating node, we will have the next as null. All the nodes will have next as null, because there is no connection we have made. We have not made any link list till now. We are just simply creating the nodes right now. Talk about the six, that will also have the next or null. This would be our node 3. And now we have to connect these three nodes. Then the linked list will be created. Correct, guys? Till now, we have only created the three nodes. And if we want to connect them, then we will be creating the linked list. So let's see programmatically, how can we create these nodes? Okay, so I think you guys will be like much aware of that we can simply create objects, right? Objects has the properties. Objects has only properties. Like we want to create a node 1, this will look like this. Value would be 4 and next would be null. By default, we are keeping next as a null. This would be node 1. Node 2 will look like this. Val would be 5. In JavaScript, I'm talking about. Next is equal to null. Correct? In the similar way, node 3 will be there. Correct? Val is equal to 6. Next would be null. Correct, guys? That's how we create the nodes. If we want to create in JavaScript, we'll simply create three objects. Everyone agrees with that? We will simply create three objects. And now our nodes are ready. So what, is there any way, rather than creating like every time these three objects, we can just simply create one template, and every time we just need to pass the value, and then automatically it returns us the object. We just need to pass the value in the function, or any way you guys just think about it. Is there any way, if we get any template where we just need to pass the value and we automatically get object in JavaScript? In JavaScript, is there any way? Yes, constructor or class. That's totally right. Because when we were talking about the class in the previous class, so I told you class gives you multiple objects. With us, like class is like a template. You will pass the values, and every time it will give you different results with same objects. So let me show you in the programs. Already created the single linked list. If I want to follow it somewhere, we'll look into here. Otherwise, we'll create a new one. Single linked list 1.js. You guys can see my screen? You guys can see my screen? Great. So see, if we want to create a node, so first let's try to create with class, and we'll give it like single or simply we can say node, right? Let's give it little bit specifically, because this is for single linked list. Single linked list node, right? Single linked list node. And how we create the nodes? We put it constructor here. In this constructor, we will pass the value. And then we assign these values to this dot val is equal to value. Value or data, whatever we want to take. We want to take data, we can take data also. That's totally fine. Data. And data is here also. And the next property is next, which I am keeping by default as a null. Right? Now let's see how we get this object. We have to do const node is equal to new single linked list node, and we need to pass the data. Like if you want to create the 4, right? And then if you want to create, this is node 1, right? And if you want to create node 2, which is the value of 5, and if you want to create node 6, like similar way, or 7, so node 3 or node 4, and 6 and 7, correct? And now if I console it, every node, console node 1, I will console every node. Node 1, node 2, node 3, node 4. That's how we create a object. Rather than creating multiple objects, in similar way, we can create the class for them. So let me run it. Node sorting or linked list. I think I have created a folder also, linked list. 1 minute. And a single ls.js. Yeah. Oh. Console.log. Yeah. Now let's print it. Can you guys see the same object which we created? Data is equal to 4, next is equal to null. Data is equal to 5, next is equal to null. Data is equal to 6, next is equal to null. So how many now we can create multiple nodes like that? Right, guys? Everyone understood? How can we create the nodes? Right? Now let's create a linked list class also, because we can create multiple. See, if we talk, please repeat. Okay, please repeat. 1 minute. Yeah. So Nilanjan, if see what we want to create a node. Node has two properties, which is data and next. So what we did, we have created one class here, and I already told you class always provides us object to us. You can see this object which is providing to us, and how we call this object with new. We have to call this class with new. We have to pass the values here in the constructor. In the constructor, we have taken the value, and then we are returning the common properties of that, which is data and next. And then we have printed it out. You can see node 1 data 4, node 5 node 4, node 5 node 6, node 7. Okay, Nilanjan? So rather than that, what we have to do, we have to create multiple objects. If we will not do this, we have to every time do like this, const, or let node 1 is equal to like this. Every time we have to copy the same thing. Data, then we have to write like 4. This is very statically fixed. It is fixed. Then next, null, correct? Then we have to go for node 2. Node 2, similar thing. It will be similar. Data, it would be 5, correct? Then would be next. Would be null. This could be node 5. I will write because node 1, 2 already we have taken. Correct? Node 6. Otherwise, Nilanjan, we have to do like this for every node. Whatever node we are creating, we have to do like this. But what we did, rather than that, we used a smart way. We created this whole object at one place, and then every time whatever next value is coming, we'll call that and create a new node, and we'll get the same structure here. Understood? Okay. Okay. Let's move further. Okay. So now, guys, we need to create the linked list also, because see, in array we can have multiple arrays, right? In similar way, linked list will also be a class. Linked list will also be a class, because we can have the, because see, array has multiple operations like push, pop, index, similar like that, right? Linked list will, because linked list is data structure, same like array. So similar way, we will also create a linked list class. Let's say class single linked list. So what are the common properties a linked list has? First thing, it has head, which would be pointing out to null if there is any empty linked list. Then we can have also this dot tail or end, which would be pointing out to this dot head in starting. Then we can also have length. In starting, it would be 0. Correct? Till now, I have not had any methods in this single linked list. Now let's look into this single linked list. Const linked list is equal to new single linked list. And if I print it out, this LL, you guys will see linked list. Head is null, tail is null, length is 0. Every time we will create a new linked list, this would be the default values. Understood, guys? This is the default value. Is this the circular one? No, no, it's a single linked list. By default, tail will be pointing out to head only, right? So again, if you guys are again confused with head and tail or start or end, these are just the pointers. By default, if the yes, that's right. But right now, this is empty linked list. So both will be pointing out the same place. Both would be pointing out the same place. Once we will insert some element, then we will remove our tail to some other places. Once we will insert some element, then we will move our are these pointers to some different. Okay, I will take pointers. I will take, say them pointer. If you guys are able to understand with the pointers, so I will then move these pointers here and there where the elements are there, wherever the elements are available. Okay. Why length? So length for calculating how many elements this linked list has. Same like array. In array we have 5 elements, so we can call array dot length. Right, guys? So that's why we have the length there. Understood, Arat? Okay, then by default, head and tail are pointing to same place. Yes, by default, yes, because it's empty linked list. In empty linked list, there is no elements. It means start and end are pointing to null only. Everyone understood why start and head are pointing to null? See, if you guys are confused with this, I could move this to null only. This is not like that. This is same. Now you guys are happy. Everyone happy now? Which part, Suraj? Not getting which part? Head null. Huh, because head is not. See, Suraj is the in this linked list, in this single linked list. 1 minute, guys. 1 minute. Actually, guys, parcel from the Flipkart or somewhere comes. So if I will not take that call, so they will go back, right? So that's why I took it. 1 minute. Okay, guys. Head null. So see, Suraj, in the starting, when our empty linked list, there is no element in the linked list. So where would be head pointing? If there is no element, where would be head pointing? It would be pointing out to null only. Now OTP also he wants to know. So that's why. Sorry guys. Yeah, OTP actually. Is it necessary to take length also, sir? Oh yes, Hariran. This is good property, right? No, not necessary. You want to know how many. If you want to know the size of linked list, then it would be great, right, to take the length there. If you want to know how many elements you have inserted in the linked list, that's great to take the size. Understood? Okay, so let's move further, guys. Let's see. Now let's talk about the operations, right? We now created a linked list which does not have any element right now. We have created one linked list which does not have any elements. We also understood how to create a node, right? Now let's try to insert elements. Okay, so now let's try to insert elements. And now guys, whatever we are going to do next, it's all visualization. Everything we will do through the visualizations only. Okay, so now let's see. This is our empty link list. Right now, head, 1 minute. Now please try to understand everything. Head and tail both are pointing to null. Correct? And length is also 0. By default, length is 0. Everyone understood? This is empty linked list right now. Everyone understood, right, this thing? Yes. Now let's try to insert 4. Okay. Now let's try to insert 4 into this. So first, always remember, for inserting, there are 3 rules. For insertion, always you need to follow 3 steps. And in the same order. In the same order, you need to follow these rules. Okay. So first rule is rules. Everyone. And you see, only you need to remember one time this rule. Every time, whatever insertion, like 100 times we will do the insertion, this rule will follow same way. Okay, so let's write the first rule. So first, create a node. Create a node for the element. For the element. So देखो 4 आया हमारे पास. इसके लिए सबसे पहले नोड क्रिएट करेंगे. So what does I mean by create a node? It means provide 2 properties to this node. अभी तो 4 अकेला आया हुआ है. 4 as a value आया हुआ है. So we need to create a node for this. So this 4 will have a value property where the same value 4 will come, and then the next also, which will be pointing out to null. Next will be null. So like once, so according to this step, so what would be the value here? According to this step, which would be one node will be created here with 4 and null. Correct? 4 would be value and null would be next. Correct? This 4 would be like this. Understood, guys? So the first step, everyone understood? Once any value is coming there, you need to create a node for that. Understood? Okay. Now we need to insert this node into our linked list. Okay. So the second rule is always first set the next of new node. Always first set the next of new node. So always first set the next of new node. So this is our new node, right? This is our new node which we are creating. So I'm saying first set the next of this node. अब देखो हम एग्जांपल ले रहे हैं. हमारे पास एक ऑलरेडी लिंक लिस्ट है. Now guys, start visualizing things. Everyone start visualization. Now your visualization skill will come here. So now I will say there is 2 which have address. There is 3 which has address of next element, right? These are nodes, right? Next. And here we have 5 which will be pointing out to null. So it means this is our end. This is our start. Now, if we want to insert a new node in this place, if we want to insert our 4 which have next also in this place, what are the steps we need to do? The first step, create a node. Okay, हमने create कर लिया. The second step I am saying always first set the next of new node. So this is our new node. इसका जो नेक्स्ट है ना, सबसे पहले उसको सेट करो। उसको सेट क्या करना है, अब देखो हमारी जो नया न्यू लिंक लिस्ट बननी है गाइस, जो न्यू लिंक लिस्ट बननी है वो ऐसी दिखनी है, 2 नेक्स्ट, 3 नेक्स्ट, and then 4 will come here. Correct guys? 4 will come here and then 5 will come. Correct? This is the here insertion has to happen. So I'm saying this particular 4 will have the address of 5. Will have the address of 5. Correct? And then 3, this 3 which is having the address of 5 will now have the address of 4. Will now have the address of 4. Then only linked list will be created, right? See, earlier this was like this. 3 was having the address of 5 and 5 was having the address of null. But now we want to create, now we want to insert 4 between 3 and 5. So what will happen? First thing, you have to create a new node. After creating a new node, first you set the next of this. First you set the next address of 4, which would be all the next address of 3, all the next address of 3. So whatever next, whatever whatever element 3 is pointing out, वो सारा का सारा point of 4 करेगा, सारा का सारा point 4 करेगा. तो पहला step ये है, first step is this, you have to point it out the, you have to first set the next of new node, and third step is then set the previous nodes next, previous nodes next to current item, to the new node. And these steps guys you need to follow in the same way. If you will follow second step first, if you will follow third step first, this will not work. If you follow the third step, then see what will happen. First you set the address of this element, address of this node. So once you will set the address of this node, all the elements after 3 will be lost. If you will follow the third step first, so this will look like this. 2 was pointing out to 3, this is the first scenario, and 3 was pointing out to 4. But what you did, you directly followed the third step first, which was you pointed out 3 to directly to 4. And then now you are going to follow the second, which is not going to happen because all the address of 3 has already lost. So now this 5 has been lost. Now this 5 has been lost. Now there will not be anything to set for 4. Now there will not be anything to set for 4 because now 5 has been already lost. Understood guys? So that's why you always need to follow these 3 rules here. Create a node for the element, then first set the next of new node. जो भी new node है उसके पहले set को करो. और उसमें क्या set होगा? उसमें set क्या होगा? What we will be setting here? We will be setting here all the address of 3. Whatever next address 3 has, we need to set that here. Okay, and then after setting the 4 address, now this 4 will point out. So see, step will be looking like this. 2 next, 3 next, correct? And still this will be there. 5 will also be there, and next will be there. So first step is step 1. Create a node. Create a node. So we'll create a node, and this node will look like this. 4 and next. Correct guys? 4 and next. Second step. Set the next address. Set the next address of new node to the previous next. अब देखो हमें कहां इंसर्ट करना है, हमें इस जगह पे इंसर्ट करना है. We need to insert in this place. तो previous क्या होगा? ये होगा. करेक्ट, प्रीवियस हो गई है. तो अब इसमें जो भी एड्रेस होंगे, इसमें एड्रेस किसका होगा? दिस विल कंटेन द एड्रेस ऑफ 5. सो नाउ दिस एड्रेस विल बी पॉइंटिंग, all the address from there will be copied here. So now this will look like this. Now there will be 2 nodes. 2 next. The first linked list is still there. 3 next. 5 next. Null is also there. But now 4, because we have copied everything which 3 has. So now the 4th next will also pointing out to 5 and null. This will be the step 2. Now the step 3. Now the step 3. Now the step 3. Now the step 3 would be the update the address of 3 next, because now we want to make this connection. Correct? So now the next would be 2.next, 3.next, and now in the 3's next we will keep the 4th. So 4 of next. Now 4 of next will come here, and automatically 4 already have 5. So you can see in the linked list we have inserted the element at the initial place, at the place. Understood, guys? It is all visualization. Whatever I did, see guys, I didn't follow the rules. I created these rules after like understanding this, how the things will happen here. Now let's talk about the first wait. First let me see. Is there any other? Yes. If anyone is confused, first let's clear this thing. Then we will think. It's all visualization. Everything will be now visualization. So Arad has one question, but he didn't ask. So Joseph has asked. Here we use swap, right? स्वैप नहीं, assign करेंगे हम directly. I will show you the code also. Assigning. So see, I think we'll talk about it, Joseph. We'll talk about the coding part. Okay. So first understand how the assigning is happening. How the assigning is happening. Can we point multiple nodes at one node? Okay, so Arad has a very interesting question. He's saying, can we point multiple nodes at one node? Because Arad, nodes has only one property, which is next. Nodes has two properties. Okay, each node has two properties, which is value and next. So with that next, only you can point at one place. So how can you point at multiple nodes? You can only point at one node. You have to create multiple next there. So see, Arad, you have to write your object like this: value, next 1, next 2, next 3, next 4. In this way, you can point to multiple nodes. This will be pointing out to 5. This will be pointing out to 2. This will be pointing out to 1. This will be pointing out to null. Understood, Arad? How can we point multiple nodes at one node? But doesn't make any sense. Why we want to do that? Understood? Okay, so everyone understood this part? How can we insert it? I just showed you logically how the things will happen there. Okay? Okay, so now let's look into the start part. Now let's look into, so there are two things happen. One is called append or one is called prepend. So append or prepend means, append क्या होता है in the real world? Append means if there are 4 people, you just need to add somebody from the last. It will append it. Correct? Or prepend means you have to add the same element from the starting position. It means prepend. Understood? Append and prepend? Like if you are trying to insert something from the start, so you will say it's prepend. If you are trying to insert something from the back, you will say it's append. Understood, everyone? Append and prepend similar. It's a like English word I was trying to explain you. Okay, so let's see. Now let's visualize how we first will do the prepend part, or like append is or prepend. Which one you want to do first? Let me, you guys tell me which one you want to do first. Append or prepend? You want to insert from the end or from the starting? Okay, till now 1 only comes. Append has come 2. Anyone else? Tell me quickly. Append has come 3. Prepend 2. Prepend 3. Append 4. You guys are just repeating it. Nicely. So no problem. Anyone can do. But I think append is little bit easy. Append is little bit easy. Let me show you why. Okay. So that's why we will start with append only, because append is easy. So append means linked list already has element. Append means linked list already has element. So it means 2 was already there, and yeah, 2 was already there, and next address 3 was also there, correct? And then we have 4 also. And if we want to append, it means, and this would be pointing to null. This next would be pointing to null. This is our linked list, right? This is our linked list. Now we want to do append. Append means we want to insert a new element at the end. Insert new element at the end. At the end. Again, 3-step rule. First step, create a new element. So now created it, and we can say that element is 5. So created a new element, 5 and null. This would be the new element, right? Step 2. Step 2, you have to set this next element to the all the previous element here, because we want to insert after this, right? Already next element is already pointing out to null, so this new element will also point out to null, correct guys? So this what will be happen? So new element dot next is equal to we can say this would be our tail also, or whatever, like we can say that right now current element, current also. So current dot next, which is null, and this new element will pointing out to null. And the third step is update the previous element, update the previous elements to next. So now current next will be pointing out to new element. This is code wise. Now let's visualize it. This is code wise. Now let's visualize it. This is 2. This is 3. This is 4. And which is pointing out to null. And we want to insert one element at this place after 4. Correct? After 4. So अब देखो हमें पता है all the last element always points to null. All the last element always points to null. So सबसे पहले इसके next को null कर दो, which is already null. When we create a new element, already null. But if it's not, then we will do it. That's what is happening here also in the second line. That was happen. So current next, it means current का next already null है. हमने इसको current माना है. We have considered this as current next is already null. That's what we assign. इसके बाद अब हमें क्या करना है? इसके next में जो current element है, इसके next में इस element को जोड़ देना है, like this. So that's what in the next line we did. Current dot next is equal to new element. That's why append was easy. क्योंकि हमें simple बस add करना है, हमें इसके next को update करना है. We just need to update this next. Update this next. बस इसके next में new element add कर दो. हो गया append. Next element is coming 6. Already next null होता है उस element का. बस ये जो last element है, इसके next को update कर दो. Understood guys? Append part. That's why append was easy. That's why append was easy, because we just need to update the last element next. जो कि last element का next null को point कर रहा होगा. It was pointing out to null. So we just need to update that to new element. That's why append was easy. Everyone understood append? So the order is ON here. Yes. But there is a one way. There is a one way to reduce that order. If we will take the tail element, if we directly, because we have, we have the tail element, tail flag, sorry, not element, tail pointer. We have the tail pointer, which would be pointing out to the next element always, which would be pointing out the last element always. So we do not need to traverse it. We will directly go to the this.tail and update it from there. Okay, guys. Okay, let me tell you one more thing. I think, see, we do not need to go to this element. Like Ekta was saying, for reaching to the last element, we might need to traverse it. We have to start, because linked list does not tell us where is the last element. Linked list does not tell us if we are not having the tail. If we are not having the tail and end, linked list will not tell you what is the last element. then in that scenario you have to start from start. And तुम्हें कहां तक जाना होगा? Okay, you guys tell me. I will see your visualization. I will tell you, I will see your visualization. So tell me guys, everyone, if you guys do not know the end position of any linked list, if you do not have any end pointer, then how will you reach to the end element in linked list? How will you reach to end element in linked list? If you have this element like 2, 3, 4, okay, let me tell you, 2, 3, and 4. These three nodes are already been created, already been added, right? Like this. And you only have start, you do not have tail or end. How will you reach to, how will you reach to end element? You guys tell me. Yes, we can check where node is null. We will just simply move by one by one. And once we reach the end, at that place, our node will be null. And that would be the end place. That would be our end place. So that's why, but we do not. So what we did, instead of that, we have taken this dot tail, which would be always pointing out to, which would be always pointing out to the last element, which would be always pointing out to the last element. So we do not need to traverse it. In this case, because we are already taking tail, so that's why we do not need to traverse it. We'll simply go to the this dot tail and take that element and try to update it. Understood, guys? Understood now the benefit of tail? Otherwise, if you do not have the tail, you have to go to the last. But you right now have already one pointer which is pointing out to the last element. Yes, it helps. Okay, now we can go for break. I think Nilanjan is looking for break now. I know I'm very excited to go for other operations also, but we can look for that after break. Okay, in that break, I could look for my parcel also. Yeah, it's my favorite too actually. I also enjoy while, because I am right now explaining these things. Otherwise, while I'm doing very quickly, I can see that okay, we need to do this next, this previous, this next, this previous. So yeah, I think I want you guys also to have the same feeling. That's why I'm trying to give my maximum here. Okay. So okay, let's go for break, guys. And right now we will come back at 12 after 15 minutes, and then we will look into the further operations. Okay, and then we'll try to implement them also, because still prepend is there. So first we'll understand the prepend, then we'll look for, then we will try to implement prepend and append in our code. Okay, guys, so let's go for break. So do append insert data at the place of null in memory or it creates a new node. So Nilu, the first step is what? Creates a new node. And at the place of null, that is not a node. So Nilu, see, the last node, all node has two properties, value and next. So last node, for the last node, the next would be pointing out to null. It means the value of next would be null. Understood, Nilu? For the last node, the value of next would be null. तो मतलब अभी कोई नया नोड नहीं है वहां पे, जो नल है वो कोई नया नोड नहीं है. Null is not a new node. Null is just the last node's value. Null node. So see, Sunilu, see, if 4 is our last node, so 4 will have two properties, val and next. Now this next value is null. Understood? And this val value is 4. So if we want to append a new element, first we have to create the new node. And then we have to update next value of null to this node value. We will update this next null to 5, this whole node. We'll keep the whole node here. And then the connection will become. Now next we'll pointing out to this new element 5 rather than pointing out to null. Pointing out to null, it means the last value. Okay. Everyone back? We still have 1 minute, I think, yeah. Okay. So now guys, we will look into the scenarios of prepend. Okay. I hope everyone is back, right? Nilanjan, Ekta, Hariharan, Arad, Likhit, everyone is back, right? Vishal, yeah. Okay. So now if everyone is back, so let's jump into the prepend scenario. Or let's wait for 1 more minute. Otherwise, if it miss, then I think it would be problematic, right? So we already have the single list here. So I will just simply in like commit the changes, right? You guys can see that. So we'll do that after understanding the prepend and append. We'll append already understood. Prepend we'll see, and then we'll do it. Okay. So I think now we can start, right? Now 1 minute has already passed. So we can start, right, guys? Okay. Let's jump into the prepend scenario. Arad is also back. Great. What about others? Is everyone back? I don't want to like. Yeah. So Ekta is back. What about Nilanjan? Nilanjan is back. I'm just seeing 20 people. I think when we started our class, it was near to 26. So 6 people, might be some internet problem. Okay. So 24 now. Okay. So for me, it's showing 20 only. You guys have might be updated value there. Okay. So now let's jump into the prepend scenarios. So everyone is ready, right? They have done a little bit breakfast or whatever they have to do. So now let's see prepend from the fresh mind. Okay. Okay, guys. So now in prepend, there could be two scenarios. Let's see. In the prepend, guys, there could be two scenarios. The first scenario, which we already had, if our head and tail are pointing to same place, are pointing to null. Sorry, not same place, pointing to null. Correct. It means our linked list is empty. Right, guys? If head if head is pointing to null, we can say that our linked list is empty. Agree, guys? So now this is the first scenario when our linked list is empty and we want to insert the element at first position. So same step. So first create a new node. So now new node would be 4 comma null. So Suman, who was that? Suman or what was the name? Earlier, Nilu. Yeah, Nilu. You can see whenever we create a new node, always this next is null. So that's why when I'm saying next is pointing to this one, it means we update this value only, the next value for that node or for that object. Okay. So now right now this is our new element. Now second thing what was this is our value. This is next. और ये हमारा new node है. New node. So second step was what? Update the new nodes next. Update the new nodes next with with the current elements next. With the current element next. But यहाँ पे कोई current element है ही नहीं. We do not have a current element. It's the first element. So we do not need to do anything here actually. We just need to assign our head. This dot head is equal to this new element, this new node, and increase our length. This dot length plus plus. This dot length plus plus. And this would be also our tail also. Tail also this would be. The same node would be tail now. Because this is the first element in the linked list. So the same the start pointer and head pointer and tail pointer both would be mapping, both would be like pointing to same node. So like this will look like this now. Now the first element has been inserted in the array in the linked list, and now start is also pointing this, or head is also pointing this, and tail is also pointing this. Correct? Because this is the first element. Understood? And ये होना है सिर्फ कब? जब head हमारा null है. If head is equal to null. If this is the scenario, if head is equal to null, it means linked list is empty. Then we just need to do this thing. That new node created, which we have created new node, we just need to assign head or tail to that pointer. Understood, guys? For the when the linked list is empty, we just need to assign our pointers to the new node, because this is the first element in the linked list. So हमें start भी वहीं करना है. वो हमारा start हो गया है, वो वही अभी हमारा tail है. Okay, understood everyone? Everyone understood this part? Now let's see the second scenario. Which is if we already has one linked list. I will go a little bit down. If we already has one linked list, which is 2, or let's keep it into the middle. Yeah. So if it is 2, and then we have 3, next, and then we have 4. Now our head will not be null, right? Guys, you guys tell me what would be my head here, where I will point head, where I will point tail. Everyone tell me, right? Head will point to this number and tail will point to that number. Write in the chat. You guys tell me in this example, in this linked list, where head would be pointing, where tail will be pointing. Everyone agrees with that? Whatever the answers are coming, head would be pointing out to 2 and tail would be pointing out to 4. Everyone agrees here? Everyone agrees? Correct. Now we need to insert a new element, which is 5. So, and we need to prepend it. Prepend it means this element will come at this position. The 5, I want to prepend one element, 5, which is null. This is the first step, right? Create a new element. I want to insert this element at the starting position. So what are the steps we need to do? First, visualize. What are the steps we need to do? So सबसे पहले क्या करना है? जितने भी elements 2 के after हैं, जो भी 2 के afters हैं, वो 5 में आने हैं. Whatever elements 2 is pointing out, all those elements now. One minute. No. 1 minute. Oh, sorry, guys. We need to. Okay. Yeah. Just 1 minute. See, guys, we need to prepend it. It means this 5 will see. Let's see the output. The final. According to final, we will understand what would be the final output. Once this is inserted, what would be the final output? Would be like this: 5. Next, it will be pointing to 2, right? Next, this would be pointing to 3, this would be pointing to 4, and this will be pointing to next null, right? This would be the final, and head will be pointing out to this, and tail will be pointing out to this, right? This would be the final array, right? After insertion, you guys tell me in the chat. This would be the final array, right? So how we will do that? How we will achieve this thing? From here, how to go like this? So for that, first we have created the node. Then what we need to do, we need to take the head element, like wherever head is pointing, take this element in one variable. So let's take temp, which will have this dot head. Correct? Which will have this dot head. So now what does it mean? It means now that we have created one more variable temp, which is pointing out to same element, which head is pointing out. Correct? Everyone understood this part? We have created one more variable temp, which is also pointing out to the value of temp. I assigned this dot head. So now head and temp will both point out to element number 2. Right, guys? Everyone understood that thing? Okay. Now what we will do, Now what we will do in the new element, इसका नाम हमने लिया है new node. अब हम क्या करेंगे? What was the second step? Update the new nodes next. Update the new nodes next. So अब हम क्या करेंगे? New node के next में we will put this temp. New nodes next we will put now temp. अब क्या होगा? इसके जो next में ना ये start हो जाएगा. This linking we did, right? With this line we did this linking. I just made it very worst. Yeah, so with this line, now this next, earlier this next is pointing out to null, but now this next will pointing out to this, because what we did, new node dot next is equal to temp. अब जो न्यू नोड टेक्स्ट है वो भी इसको पॉइंट करेगा. अभी तक हेड और टेम्प कर रहे थे, अब जो न्यू नोड का नेक्स्ट है वो भी इसको करेगा. राइट गाइस? So now the new node next will also point out to this. Now what is the next thing we need to do? Now, next thing is we need to update our head, because now earlier head is 2, but now we need to update our head to this new node, because now now this new node will become head. So the next step is this dot head is equal to new node. अब जो this dot head है वो new node को point करेगा, इसको. करेक्ट? अब ये हमारा हेड बन जाएगा. एंड नाउ वी हैव इंसर्टेड अ न्यू एलिमेंट एट द 0th पोजीशन, और वी हैव डन द प्रीपेंड. अंडरस्टूड गाइस? सी, एवरीथिंग गोज विद द विजुअलाइजेशन हियर. वी हैव नॉट डन एनीथिंग like extra like you know the crazy thing. We didn't do any crazy thing और कुछ ऐसा अलग सा नहीं किया हमने. We just visualize it and then we written the code at the left side. सबसे पहले हमने क्या किया? Always we followed 3 steps. फर्स्ट क्रिएट अ नोड क्रिएट करने के बाद जो हमने नया नोड क्रिएट किया, देखो आई एम आल्सो एक्सप्लेनिंग इन हिंदी, whoever is good in Hindi they can also catch it quickly. तो सबसे पहले हम विल क्रिएट अ न्यू नोड. हमने एक नया नोड क्रिएट किया. नोड क्रिएट करने के बाद जो भी नया नोड है उसके नेक्स्ट को पहले अपडेट करना है. हमें सबसे पहले ये सोचना है कि जो नया नोड है उसके नेक्स्ट को कैसे अपडेट करें. ओके, वी हैव टू थिंक हाउ कैन वी अपडेट द न्यू नोड नेक्स्ट. Once we updated the new node next, then we have to think, now the third step is कि अब जो हमारा new node का next update हो गया है, अब इससे जो पहले elements आने हैं उनको कैसे जोड़ा जाए इस नोड के साथ. अब देखो, अगर हमको किसी एलिमेंट को बीच में we have to insert it into the middle, then we need to attach that element from both sides. Correct? If we have to, like if there is a 4, there is a 2, there is a 3, and if we want to insert a new element in this place, so like 5, so we need to attach this element from both sides, from here also or from here also. Correct? So in this place, so first step is create a node. पहला step है node create करो. दूसरा इसका जो next है उसको पहले update करो इसके साथ. Okay, first make this connection and then make this connection. That's what we are doing everywhere. You can see in this place also, first we created a new node, then we updated this thing. You can see this is the second line which made this connection, and then we updated our head, which makes like but here we do not have any previous element, so that's why we did this dot head here directly. But if there is any previous element also, like we have seen earlier, right here we have seen the previous element, so you can see the next line was current dot next is equal to new element. तो जो करंट है अभी उसके जो नेक्स्ट है उसको फिर अपडेट करो. सबसे पहले ये कनेक्शन बनाओ फर्स्ट, देन दिस. ओके, सो दैट्स ऑल. ऑलवेज नीड टू रिमेंबर दीस 3 रूल्स, एंड अकॉर्डिंग टू दीस 3 रूल्स वी हैव टू इंप्लीमेंट. गॉट इट गाइस? प्रीपेंट अंडरस्टूड? इन प्रीपेंट देयर वाज 2 सिनेरियोस. First scenario, if we do not have any elements in the linked list, so simply head and tail will point to the new element. First scenario. Second scenario, if we have elements in the linked list, then we need to follow the 3 rules which we already discussed. Okay, sir, I think we can also work without creating this extra temp pointer by directly using the head. Yes, we can do that also, but it's better because right now we are working with the objects. So in sometimes क्या होता है objects में they create the link. So we are updating something here it updates some other places also, because they do not deeply clone it. When we are trying to pointing out, so sometimes what happens, if we are trying to update something, so some like from the original part also got updates. So that's why we always try to create a new variable and keep try to update that variable, rather than doing all the operation on head and head or tail. We always take these values in one variable and then try to do operations on that variable. So that this dot head will not be impacted. Okay. So Joseph is saying, please repeat that temp part. Okay, Joseph. See, this is the first thing, right? So what we did, Joseph, here, we just we just created one more pointer, the temp here, so we can easily traverse in the whole array. We always create the pointer here, traverse in the arrays. We very less use head and tail to update, because we always want our head to at the correct place and tail to correct place. Like if we want to move in this array, so this we will move through this temp variable rather than through the head. So let's see, if we want to go to the next element, we'll go through the temp. We will always move our temp pointer. We will not move head and tail. We will keep our head and tail at the same position always. We will not these positions. Okay, we will always traverse through the temp current, any variable we will create. With that pointer we will only traverse in the array. So that's what we did here. First we did whatever head was pointing, I kept the temp also there. So you can see temp is equal to this dot head. It means whatever head is pointing, temp will also point it out. Okay, so that's what we did. Temp is equal to this dot head. So temp was pointing this whole linked list. Temp is now also pointing the same linked list. Then what we need to do next? The second step here, which was we need to update new node next to this. We need to make this connection now. We need to make this connection. अभी connection कैसे बनेगा? So हमें इसके next को update करना होगा. We need to update this next. So how we will update? New node dot next is equal to temp. So all the values, whatever the elements were coming in the temp, whatever elements temp was pointing out, now all will be pointed out with the new node also. So now this will be pointing out here. Then we will update our head, because now we need to make this head this element. So now we updated this dot head is equal to new node. You can see this is the final output. First step was creating this thing. Second step was point out everything which temp was pointing out. Then make a new element to head. So that's what we were doing with the temp element. So reason why we have taken the temp, we can do with the this dot head also. But the reason, as I explained, why we are taking always the temp, why we are not always traversing with this dot head or this dot tail, because we always want to keep the correct position of head and tail when we start traversing. We always want to keep the position of head and tail at that place only when we are starting the iteration, when we are starting our iteration. Understood, Joseph? Why we are having the temp part there? Okay, so now everyone understood this thing. Now let's jump into the code. Everyone tell me in the chat. It means having any backup. See, Hariharan, reason for that is, see, if you are traversing in the middle, like there are 5 elements. Start from 0 and ends tell ends at 5th index, correct? So जब तुम third element पे हो, when you are at the third element, you do not want to move your head to third element. Your head is still first element, right? Okay, still confused about that. Okay, no problem. I know. It could be a little bit confusing. So see guys, this is our 2, this is our 4. When I'm doing arrow, it means they are pointing out to this element. Then null is here, right? Let's add some more elements, like 5, 1 is also here. Okay, so now Arad, Hariharan, Joseph, again, head will be here. You know that head will be here, and you know that tail will be here. Till now we are good, right? Hariharan, Joseph, and Arad. Okay. Now what we want to do, we want to find it out that in this linked list element 4 exists or not. We want to find it out in this linked list element 4 exists or not. ठीक है, अब हम क्या करेंगे? How we will find it out? The one way is the first way. We start from head. We start from head and then check for the next element. Correct? Check for the next element. Okay. And then what? Then the one first way is start from the head and then check for the next element, which will be 2. Then we will move our head to this position, because same logic will run here also, right? So logic, what will be the logic? If head dot next, this will be loop, right? If head dot next is not null, while this would be the first way. If head dot next is not null, just continuously move our head. Head is equal to head dot next. Correct? And here we will look for that element which we are trying to find it out. Like this. If head dot value is equal to 4, यहाँ पे हम अपना कंसोल कर देंगे और रिटर्न कर देंगे. Correct, guys? This is one way. Right? We are just traversing one by one head dot next. और जहां पे हमें वैल्यू मिल जाएगी, wherever I will find value, we'll simply return it. This is one way. Understood? Hariharan, Arad, you understood? We are just traversing head to head dot next, head dot next, head dot next, and till we got the null, we'll just traverse it. Okay? This is one way. So now see the problem here. Definition of head is head should always point out to first element. Definition of head is we should always no we are overriding head here. That's right. But what is the definition of head? Head definition is head should always point out to first element wherever we need it. But you can see here in this scenario, when we will be in the fourth element, head would be pointing out to this. Head would be pointing out to this. Now, if somebody is trying to find it out, the next element like 2. Now, if somebody is trying to find it out, the element 2. So now they will find head at 4th position. Now they will find head at 4th position, which is not correct. Head should always be at the 1 position. Head should always be at the 1 position. But what we did, we always override our head value and then we moved it further. So that's why we never go with head. Rather than that, what we do, we keep all the values of head in one variable. We take one variable like temp or whatever value is that, temp. Then we will assign all the values of head into the temp, and then we will do all the traversing with temp only. And head will always be here. Head will always be there. Got it now? Everyone got it completely? Like Arad, Hariharan, or Joseph, you three people were facing problem understanding. Understood now? And yeah, it clears, I think, Ekta's doubt also. Ekta was also asking the similar thing earlier. But yeah, it will clear that also. Okay, so now let's start writing the code. Okay, and we will start with prepend. We'll start with prepend. Let's quickly see what we already did. So we created one node. Node always has 2 properties for single linked list, which is data and next. Correct? Next will always be null for new node. Then we created a single linked list. Single linked list will always have head, tail, and length. Understood, guys? Any question for these 3 things? Whatever we did in this part? Any question? Head is pointing out to null right now. Head and tail both are pointing out to null. Okay, let's start. Let's create first method, which is prepend. Okay, so which would be somebody is passing us the values that we have to prepend. So it will call like this: ll linked list dot prepend. Prepend this element. Correct, guys? and we'll take here value. Okay, so what is the first condition we need to check? What is the first scenario for prepend? The first scenario is if our head is the two scenarios, right? For prepend, there is two scenarios. If our head is null, or if our head is not null. Correct? If our head is null, then what we need to do? We just need to create a new element and point our head or node, head or tail to same node. Correct? So let's try that. Let's take the first situation, which is if, look, before that, create a new element first. Const new node is equal to new singly linked list node and pass the value there. Right, guys? We got the new node. Everyone understood this part? We got the new node, right? Now what we will do, if this dot head is equal to null, if this dot head is equal to null, in this scenario, what we need to do, we need to simply point out this dot head is equal to new node and this dot tail is equal to new node. And then we will increase our length also. Correct, guys? That's what we need to do for the first scenario. If our head is null, we need to point our this dot head to new node, this dot tail to new node, and this dot length plus plus. Okay? Okay, before going into that, guys, let me create one more function, which would be a print. Before that, I'm just creating print list. So we can simply see the values also. Okay? And this print list will work like this while, again, take the temp here. This dot head, okay, और जब तक ये head temp null नहीं हो जाता तब तक while loop continuously run it and put the values temp dot value data temp dot data, and then do temp is equal to temp dot next. Temp is equal to temp dot next. Correct? This will print all the values. Correct, guys? This will print all the values. Sir, use okay will look good. Okay, so you are saying like this, right? Temp dot data and like this, or before also. Okay, let's see. Yep, I think that designing you can do later also. But yeah, let's see. So this how. So see, जब तक null नहीं हो जाएगा, we will move into temp dot next, and once we got the temp, we will stop there. This while loop will stop there, and we will print all the values of temp. Correct? So this is the simply print list, and what yeah, come here in this scenario, and thus after that we'll simply return this dot print list. So we'll print our linked list there, and let's see how that looks like. So guys, I will console first. I will console first the original linked list when it was empty. It is when it was empty linked list. So how does that look like? And then I will show you after prepend how that look like. So yeah, so let's run it. Node linked list single linked list dot js. Okay, I have taken the wrong variable. Yeah. Temp is equal to temp dot next. 1 minute. Oh, we have taken const. Sorry, it should be let, right? Const we can't update it. Yeah, guys, see that. This is our empty link, single linked list. Head is equal to null, tail is equal to null. Let me also print the, like after that, after prepend, how the linked list look like. Linked list. You guys can see that, right? How the empty linked list looks like, where head is equal to null, tail is equal to null, and length was 0. But you can see now after prepend, we were also doing the print list. So you can see only one element has been inserted. So you can see temp.data has been printed 4 here, and then you can see your linked list also. So head is pointing to one linked list node, and tail is also pointing to 4, and length is 1. You can see head is also pointing to 4, tail is also pointing to 4, and length is 1. Understood, guys? Everyone understood? You have already seen that, right? Head is also pointing to 4, and tail is also pointing to 4, and our length has become 1. Correct? This was the first scenario. Sure. This is the entire code. Let me okay, yeah. Let's start from here. This is our single linked list node. Okay. Then we have single linked list. We started our linked list here. This is the constructor part, like default values for that linked list, where we have head, tail, and length. Correct. Then we created the prepend method inside this class. The first step, always create a node. So we have created first node. Then we are checking if this is the first scenario or second scenario. If this dot head is equal to null, it means the first scenario. So simply point out head to that node and tail to that node. So that's what we did. We assigned these values to these head and tail. Then we increase our length, and at the end we are calling print list. So whatever element we have assigned, we will simply print it. That's what we are doing the printing here. Understood, guys? Okay, now let's talk about the second scenario, guys. Now let's talk about the second scenario, which was if we already have the element. This one. Yeah, this one. If we already have the element, what we did? So that's what. First, we have taken the temp. Okay. So let's go for the else scenario. What is the first thing we did? First, we take the temp, where we will store our head. Right? So now let's draw it again, no problem. 2 is there, 4 is there, and 6 is there. And then we have null. Correct? Our head is this place. Correct? So now, we want to insert into this one at the first position. So first, take this head into next variable. So it will be let temp equal to this dot head. जैसे हमने ये किया, temp will point out here. Already visualize it everything. Whatever we are writing in the code, visualize it. So now this, when we will do this, let temp is equal to this dot head, temp will be pointing out to this one. Okay. Now second step, we have already created the new element. So update the next value of this. So new node, not dot next. It means this part. New node dot next. This part. अब ये किसको पॉइंट करना है? इसको पॉइंट करना है पूरी लिंक लिस्ट को, पूरी की पूरी लिंक लिस्ट को. So simple is equal to temp, because temp is also pointing out to this. So if we will assign temp to here, this will point out to whole linked list. Correct? This is the second step. Correct? What is the next step? Now we need to make this element to our new head. This will be our new head. So now this dot head is equal to new node, and then this dot length plus. That's what we are going to do, guys. You see in the code also. First we have taken this dot head into temp. Now in new node dot next equal to temp, and then after making this second connection, now this connection is made. Now this connection is there. Now we need to make this node our new head. So now this dot head is equal to new node. Okay. New node. And then this dot length plus. And then again we will print it return, because with the printing we will see we will get how the values are looking like. Okay. Now let's prepend another one. So first we have prepended the 4. Now let's prepend 5. So how this will look like, guys? How the prepend 4 and 5 will look like? So first 4 will be inserted, and then 5 will be inserted before this. So now the linked list look like this, right, guys? Now head would be at this place, tail would be at this place, and length would be 2. Correct, guys? Correct? That's how we need to look. That's how it should look like. So let's run it. Let's run it. So now I can remove the empty linked list. This one, this console. We do not need it. Now you can see, guys. This is the first time when we prepended the 4. At that time, we also called the print list, right? So that's why the 4 is only coming at that place. Now next time you can see the 5, 4 comes. So now you can see the second time when we prepended the 5, 4. So now 5 has become the first element. Now you can see the final linked list. This one, final linked list, which looks like this. The head is pointing out to 5 and tail is pointing out to 4. And in this node, next is pointing out to 4. The similar way, right? Similar like this. 5's next. 5's next. 5 next should be pointing out to 4. That's what happening here. You can see find next is pointing out to 5's next is pointing out to 5's next. This is next of 5 pointing out to 4th element, 4th node. And you can see tail is pointing out to node data 4. Understood, everyone? We are updating the tail only at the first element, because that's the only first element which will be updated, right? Tail will always be the first element. Tail, in the case of prepend, tail will always be at the first situation, because ekta prepend means we are trying to insert every element at the previous position. So जो भी पहला element हमने insert किया है, that will always be tail. Tail will not be updated in the prepend scenario. Understood? In the prepend scenario, tail will only be updated when head is null. After that, you are trying to insert. Okay. I think you might us confused. Okay, when. Okay, so first time, guys, let's talk about the tail. Ekta is confused. I'm not sure others are also confused or not, but let's see. When the first scenario, when head is null, tail is null. Our linked list is empty. We inserted first element 4. So now our tail has become 4. Head is also become 4. Correct? First scenario. Now second scenario. We are trying to insert 5. Insert 5. Now, and we are trying to insert 5 as a prepend, as a before 4. So now 5 will be here and 4 will be here. Now you can see tail will not be touched. Whenever we are doing the prepend, tail will not be touched. Now, if you want to do insert 6 also, at prepend, again 6 will be this, 5 will be here, 4 will be here. Tail will not be touched. Tail will only be touched in the first scenario. Head will always be updated. Now new head, every time new head is coming, not the tail. Tail is whatever we inserted first time. That's the tail. Understood now? Correct. We are moving head to left side, because every time append mean what? Prepend mean what? Prepend mean insert something at the first position. So first position में insert कर रहे हैं, it means head will change. Understood, guys? We can do reverse as well. Yes, we can do reverse as well, but why do you want to reverse it as well? Oh, we will do the reverse when we want to delete it. Arad, when we want to delete something from the end, we will move our tail to the previous position. See, Arad, when we want to delete the 4, so we will move our tail to this position. Correct? When we want to delete it, at that time, we will move our tail to this position. So when head is not null, we do not touch the tail. Yes. for the prepend scenario, in the prepend scenario एक था, क्योंकि देखो ऐसा ये याद मत करो, do not remember these things. In the prepend it means logically visualize it. In the prepend हमें हमेशा आगे इंसर्ट करना है, हमें we ought to always insert in the front, insert at the first position. So tail will never be touched. Logically, first think logically, then say yes, this will not happen. But when head is not null, then we can say that we will not touch the tail. But this is because in the prepend scenario, you always have to insert at the front position. So tail will not be touched. Tail will always be same. Whoever the element which has been inserted first time, that will always be tail. Okay? Understood everyone? About the tail, why we are not touching tail in the prepend scenario? I mean, can make head untouched and tail move. Untouched and tail move. Yes, we'll do that. We'll do that in delete scenario, right, Arad? And in delete scenario only we do not need to touch head, right? We have to if we want to like if see in the append scenario. Now we'll do the append scenario. In append scenario only tail will be touched. Head will not be touched. अरे ये तुम अपेंड प्रीपेंड को फर्स्ट समझो ना, एवरीवन फर्स्ट अंडरस्टैंड अपेंड एंड प्रीपेंड. अपेंड में क्या है, वी हैव टू इंसर्ट फ्रॉम द लास्ट, सो इट मीन वी हैव टू प्ले विद टेल, we have to play with tail or end, right? In the prepend scenario we have to insert from the front side, so we have to play with head only. That's the append and prepend, right? Definition of append and prepend. In append we have to go from the back side, in prepend we have to go from the front side. So wherever, and we have pointer at both places. At the back side we have tail, at the front side we have head. So जब भी हमें front से insert करना है, we will touch only the front one. Understood, everyone? Yeah, it's very simple. Yes. So Hariharan was asking about explaining the print list method once. Okay, sure. So Hariharan, print list में क्या हो रहा है? What is happening in print list? So print list में क्या हो रहा है कि we have already created our linked list, right? So right, you can see in the print list we have already our linked list. So like this, 4 which has next, 5 which has next, then we have 6. Okay, and then next is null, correct? And here our head is. Okay, Ariran? So what is happening in the print list? First we pointed out our head to one different variable, which was temp. So now temp is also pointing out to this. Okay, now temp is pointing out to 4 comma next. So now what is the loop we have kept while temp is not null? It means जब तक temp में null नहीं आता है, तब तक ये this loop will continuously run till we got the null, and this null will only get when we will reach to this position. Correct? So now let's see what is happening inside it. Now you can see temp in pointing out to this object. So I can see temp is pointing out to this object, which has val as 4, next has address of 5th, address of 5th. Correct? Temp as val and next has address equal to 4. That's what this pointing means. Now temp is assigned to this value. So now what we are doing in the loop, first we consoling out temp dot value. You can see first we consoling out temp dot value. You can see temp dot data. So that's what. So now first time this 4 will be printed out. So now this will print 4. Now we need to move our temp to next element. Now we need to move our temp from here to this element. So what we will do? Temp is equal to temp dot next. जो भी इस temp का next है उसको अब temp बना दो. So temp is equal to temp dot next. So now this 5 will be coming here. Now this temp will be moved from here and point out to 5. Correct? Now again this temp will be pointing out to 5. Value is equal to 5. Next is equal to address of 6. Address of 6. Again temp dot val will print 5. Correct? Once we printed out 5, again do the same thing. temp is equal to temp dot next. Temp dot next. अब ये जो temp है, this term will point out to 6. Correct? So now we'll go for next temp. Temp is equal to val 6, and here next is null because there is no element next. Next is pointing to null. So now again we'll do first temp dot val, first line. It will print out the 6, and now our temp will again temp dot next, which is null. Now this temp here while loop will stop, and you can see we have printed all the linked list element. So first we will print 4, then 5, then 6. Understood, Hariharan? Understood? Yeah, we are not touching head value. If you are saying head value remain constant, yes, we are not touching the head value. We are touching the temp value. Head is still same. We have not changed anything in the head. We have changed only the temp. I am not saying anywhere head has to be changed. Head has to move. No, temp has to move. Yes, we are just finding all values of nodes in linked list. Okay, now let's look for the append value, which was very easy, right? Append. We have done the prepend. Now we have to do the append. Means insert from the back side. Just visualize it. What are the changes you need to do? Just visualize it, guys. Now what we need to do? Very quickly. Let's quickly look into that. If we have 4, if we have 5, if we have 6, correct? These many elements, and head is pointing out here, and tail is pointing out here, and this is pointing out to null. This next of this is null. Now we want to insert one element at this position, 7, common null. So what are the changes? First thing, same. First step is, what is step 1? You tell me. Let me check in the chat. What is the first step while inserting any element? Create a new node. Correct. So that's what in the code we will do that. Create a new node. So let new node is equal to new single linked list node and pass the value. Correct. We have created the new node. Agree? We have created a new node. अब देखो, after creation the new node, our step was update the new nodes next. Update the new node next. But we know that this is the append scenario. Always be the new node next would be null in append scenario. In the append scenario, क्योंकि ये last element है, so last element always be null. Or last elements next always be pointing out to null. So that step is not needed. That step is not needed. So what we need to do here, we need to make the third step, which is making this connection. This connection is already there. This connection is not there. This connection is not needed because when we create a new node, next is always null, and we need a null. We need to make next as a null because that's the end element. But so that's why step 2 is not needed in append scenario, but step 3 is needed, right? We need step 3, and for that what we need to do, again we need to take one temp variable which will be pointing out to tail this time. We'll take one temp variable which will be pointing out to tail this time, this dot tail, and then then temp dot next इस element के next में temp dot next is equal to new node. This is the third step we do, right? If you remember, this is the third step we do, where we assign our new node to next. This is the third step we do, but here we do not need the second step. That's why. And then after that, we have to assign our this dot tail is equal to new node. क्योंकि अब हमारा जो tail है वो ये बन जाएगा, this dot tail. Understood, guys? And this will move out to null. So what we did, just visualize it. Just visualize it. तो जो टेल अभी जहां पॉइंट कर रहा है, wherever right now tail is pointing, उसके नेक्स्ट में न्यू एलिमेंट आना है. very quickly see, जो wherever tail is right now, उसके नेक्स्ट में न्यू एलिमेंट आना है, or we have to make new tail now, because now this will not be tail, this will be the tail. That's what we did. So rather than, so again, tail dot next we will not do. Tail dot next, no, that's not good way. Hariharan, Likhit, tail dot tail, we will not do the tail dot next or anything like that. We will first take the temp variable here. We'll take the temp variable here. We'll do with that. That's a good practice, I will say. So this dot tail, right? And then we'll do the temp dot next, which is same, This dot tail dot next, temp dot next is same. Temp dot next is equal to new node. And then this dot temp. Now we are updating our this temp to new node. Correct? And then this dot length plus we have increased our one element. And then at the end we can return this dot print list. It will print all of the elements whichever is created. जो भी हमने नया element insert किया है, append किया है, it should come at the last while we are doing the print list. So let's see that. Let's do the append. ll dot append, and we have to append 6. So according to me, the print should look like this. The print should look like this: 5, 4, and 6. 5, 4, and 6. It looked like this because 5 is prepended before to 4, and then 6 is appended. So let's see. Let's see how this look like. Can you guys see that? The last one, 5, 4, 6. And can you guys see that? Tail is now become 4. Earlier tail was 1 minute. I think something we missed it. 1 minute. One more thing we need to do here. Temp is equal to new node. 1 minute, guys. 1 minute. This should be null, right? So, okay. Temp is equal to this dot tail. Okay. That's correct. And then temp dot next is equal to new node. Okay. So temp would be 4. Okay. And then this, oh, sorry, this dot temp I did. Oh, that's what the mistake actually. This dot tail, not temp. This dot tail. That was the problem actually. Yeah, now you can see, right? Head is coming as the 5th, tail is coming at the 6th. Oh, actually, I did this mistake. We have to update the tail, not the temp. Yeah. Yes. Understood, everyone? Let me see the questions. So tail dot next, this dot tail, temp is equal to this dot next, line number 38, okay. Okay, thank you, Ariran. Yes, this dot tail. Temp to tail, yes. Thank you, Joseph. Tail is equal to temp. Sir, we are dealing with objects and it's passed by reference. Do we need temp? Sir, we are dealing with objects and it passed by reference. Do we need temp? Oh yes, actually we need temp, right? Because temp will create a new memory for that. Temp will, because we are updating only temp. It's not going to update the original object. It's not going to update the original object. You can check it. If we are updating the tail, if we are updating the temp, let's see that. If that's the scenario, let's see it. Let's see that. Let's confirm this thing. I will print here this dot tail. Till here, tail should be same, right? Till here, tail should be same as the earlier. It should be pointing out to 4. Let's see. You see, tail is still 4. Understood? We have updated the temp next. But you can see, tail is still 4. Oh, 1 minute. Oh yeah, you are right. Yeah, I think Vishal is right. Yes. That's all that's happening actually. Pass by reference, it's happening. You see, temp, whenever we are updating the temp, it's also updating the tail also. That's right. right? Correct. Let's print it out before this. We would be confirm. Just checking one thing, guys. 1 minute. Yeah, that's right. That's happening. Yeah, so I think we can go with the earlier approach also, the pass by reference. So we can go with the temp dot next also. Sorry, tail dot next, because I think that's already happening. Because yes, Vishal has said it correctly. Because we are right now in JavaScript, we are working in JavaScript. In JavaScript, when we are assigning any new variable to like objects, it always take the reference, not the value. It always take the reference, not the value. But yeah, it's better actually. The best practice is always take an example, always take another variable and then do that. Okay, then do that. To tell now, we have to assign temp to tell. You have assigned new node to tell. New node to tell. We have assigned new node to tell. Yeah. So we have to assign temp to no. Why we need to assign temp to tell? Temp is the previous element. Temp is the previous element. So in this example, temp is this one. Joseph, temp is this one. So we do not need to assign temp to tail. This is the new element. This new element has to be tail. So that's why this dot tail is equal to this new element. Understood, Joseph? Temp is the previous element where tail was earlier. Where tail was earlier. That was the temp. You can see this is the first line. Here temp is right now. This is the tail was earlier at this position 6. Right now here tail is. Once we inserted a new element, we have to update our tail, and that would be updation with we have to update our tail to new node. Understood, Joseph? Okay. Now let's see one more scenario, and then we will close today's class. Sir, please explain the last output which come after append. Last output which comes after append. Let me run it again. This one. This one, Hariharan. The whole linked list. Yeah, so this is a whole linked list which we are printing. You see, in the last console.log, this is a whole linked list which we are printing here. And you can see in the head is pointing out to 5, tail is pointing out to 6, and length, whole linked list length is 3. That's these 3 things in the constructor. Wherever head is, everything is here, head. Wherever tail is, those values are coming. Understood? Understood, Hariharan? Okay. So now let's see, guys. There is one more scenario which is coming after prepend and append, which is insert at. Like if somebody wants to insert at any position, insert at. This is good one. They want to insert at any other index, right? Position or index, anything we can take value. This one is little bit like thinking. Thinking is needed here. Let's see. I think we have already discussed. I think this scenario we have already discussed. Yeah, here. We have already discussed this scenario, but we will try to discuss it again. So see, in this scenario, there could be 3 scenarios. If somebody wants to insert at the 0th position, if somebody wants to enter at the last position, which would be equal to length, or third position between 0 to length, between 0 to length, right? This could be only be three possibilities for insert at any positions. Only 3 possibilities at the first position, or at the second, or at the last position, or in the middle. Only 3 places we can insert. Everyone agrees with that? Okay, I think guys, I will just push this change. and I want you guys to try it, and then we will look into our in next class, because I think you guys now get little bit visualization, right? But let me give you one hint here. Let me give you one hint here. So like if our position is 0, if our position is 0, we just need to simply call our prepend method. Return this dot prepend, right? Because prepend is the one who is inserting at a 0th position. Who is inserting at the 0th position. Correct, guys? Or what about the second scenario? Second scenario is when somebody wants to insert at the last position, which is if position is equal to length, this dot length, or this dot length minus 1, I think. Right? This dot length minus 1, because we are talking about the indexes. We are talking about the indexes. So position is equal to, so in this place, we will simply call our return this dot append with value. Are we good with this scenario? These two scenarios, did we understood? If we are at a 0th position, length spelling is wrong. Okay. Oh yeah, length spelling is wrong. Are we understood these two scenarios? If somebody wants to insert 0th position, it means he wants to do prepend. If somebody wants to do at the end of it, it means he wants to do append. Now we look on the third scenario. We can put one else if condition, one more condition, just to check the position value should be between these two. Because length is 5. If linked list length is 5, then the indexes wise it would be 0, 1, 2, 3, 4. Understood, Vishal? If the linked list length is 5, then in indexes wise it would be 0, 1, 2, 3, 4. And when we are talking about position, we are talking about the indexes. Understood? Repeat which part, Joseph? If somebody wants to insert at 0th position, we will call the prepend. And if somebody wants to call the last element at the last position, which would be length minus 1. Yeah, that's what I'm explaining. If somebody wants to insert at the last position, it means it would be linked list length minus 1. That would be the last position. And there we will do the append. Now the third scenario, guys. Now for the third scenario, multiple ways are there. Multiple ways are there. Now the third scenario is if somebody wants to do the insertion at the middle elements, right? So if we create any element like 2, 4, 6, 8, and if somebody wants to create insert at the like second position, like these are the indexes 0, 1, 2, 3. Somebody wants to insert at this position, right? Somebody wants to insert 9 at this position, correct? So what we need to do, guys, somehow we need to reach there. This is our head, this is our tail. Somehow we need to reach to this element. So see, logically first thing, sub ignore karo, just logically think how we will be inserting this. How we will be inserting this 9. So 9 should be make connection with 6, and 9 should also make connection with 4. Correct? 9 should also make connection with 6, and 9 should also make connection with 4. Then only it will look like this: 2, 4, 9, 6, and 8. Correct? 9 has to make connection with 6, 9 has to make connection with 4 also. Agree, guys? Agree? That's how the connection has to make. So correct. So you can see now two nodes we need to, like at the same time we should have 2 nodes. At the same time we should have 2 nodes. One is the current position. Somehow we need to reach to this position, and we should also reach to previous position. This would be our current position, like because somebody has asked second position. Somebody has given, he wants to insert at the second position. So somehow first we need to reach to second position. While we are at the second position, we should also have something for our previous element also, because we need to do operations in both places. because we have to update previous next, and we need to update our nines next to this element. You can see the connection. We have to make two connections. This is the connection, this is the connection. This connection has to make with previous node, and this connection we need to make with 9. So I am just giving you this task. How will you do that? I will push that much code, and I want you guys to think about first how can we reach here. So I think that's very easy. That's very easy. You can take one variable here, count variable, which would be starting from 0, like the index, and then you will go into the loop of while, and you will say कि count जब तक till count is less than position, do the count plus plus, do the count plus plus, do the count plus plus, and do the current is equal to current dot next, current dot next, current dot next. And what would be the current? Current would be our head. Let current is equal to this dot head, because always we have to start from our head. और फिर सबसे पहले हम यहाँ से स्टार्ट करेंगे, हमारा करंट आ जाएगा यहाँ पे, this will be our current. Then we will move our current to this place. Count is still less than position. Again we'll move to this place. Now we reach to this node. Now our current will be pointing out to there. But somehow you need to think how can we get the previous also, because we are at the current. Current will have two things only: value, which would be 6, and the next, which would be next address of 8, address of 8. Now you need to think something, little bit think how to get this previous element, how to get this previous element. And that's what I am giving you as a task, homework, and I want you to think about how can we reach to previous. And once we reach to previous, it's very easy. Previous dot next, उसके next में हमको current node डालना है, ये connection बनाना है. So previous node next is equal to current node, और current node के next में current डाल दो. Oh sorry, new node. Sorry, not current node. Sorry. Previous node next is equal to new node. New node, और new node के next में current node. New node next is equal to current node. That's what we need to do only in the code. But we need to find this previous first, क्योंकि इसके previous के next में current new node आएगी, और new node के next में current node आएगी. So we have already reached to current, but somehow you need to think about to reaching to previous. And that's what I am giving you this as your homework. You just try it, and then we will talk about it in the next class. So Ekta is saying for third situation, we will traverse to that position. Yes, that's what I already traversed it. And then insert between two nodes by manipulating the next pointer of 3 nodes. 3 nodes, third nodes, 3 nodes. I didn't understand the last line, Ekta. So yes, okay. Yes. So in the current node, we do not need to update anything. In the current node, guys, you can see, in the current node, I'm not updating anything. I'm just updating in the previous node and the new node. This is the part only which is getting updated, previous and new node. But new current node is just giving us the where we are at right now. So current node, we are not manipulating anything. But yes, the tricky part is how to find the previous one. That's what you need to think. I want you guys to think about it. Do not copy paste it. Just think. And I am telling you solution in this loop only. Solution is in this loop for finding out the previous element, but you need to think about it. Okay, that's a homework. Let's see. Meanwhile, Likhit has said anything, and he has also said doubt. Traverse only till previous node. Since previous nodes contain next address, we can keep that in new node address, and previous node address will be new node. So yes, let's try that one also. You are saying traverse till previous node. It means you are saying whatever the counter value is, we should traverse till -1. We will get always the previous node, right? So yeah, that could be one way. That's why I'm telling solution is in the while loop. Solution is in a while loop, but there is one more way. That's also one way. which Likhit has suggested. So let's see if we follow that way. So we will reach to the previous node, and in the new node, okay. So we have to take one variable, and then we need to store that previous next, and yeah, that will also work. Definitely, it will work. We can keep that in new node address and previous node address will use. Yes, that's one way. This, so think about some other ways also, Likhit. Okay, that's good. You think about this one. Think about if you do not want to reduce the position. Is there any other way to do that? So think about that also. Let's see the Likhit code. While I is not equal to, that's what you did, right? I understood. I understood this part. You have just subtracted one. You didn't go to the last position. You just went into the previous position. I understood this part. Then what you did, new dot next is equal to temp dot next. Okay, and temp, it will work. It will work. You have to do this dot length plus plus also. But yeah, think about something else. If you do not want to reduce the positions, is there any other way? This is correct, click it. Okay, but think about it. Okay, so see, Vishal, there is one screenshot which I will share in the group. I will share that in the group also, in which I created, which will tell you the difference between array and linked list. Okay, which will tell you the difference between. So see, the reason for so the reason for that is yeah. So you're asking about the linked list. So yeah, so let's come back. So why we are using the linked list? The reason for that is with the array, when we are using arrays, we are restricted. We are restricted with the memory space because arrays have contiguous memory, right? If you want to like insert any element at the fourth position, like if there is any element, if there is one array and in that array 4 elements are there, 0th, 1 and second and third index. If you want to insert something at the second index, you need to, what you need to do, you have to first increase the size of that array. From 4 you have to increase till 5, and then you have to copy, like you have to again do the iteration. You have to first insert 0 to till 2, then insert the 4, then insert the fifth element. So inserting and deleting in array is very difficult. So that's why the linked list helps us there with two scenarios: insertion and deletion. Linked list helps us a lot there. And then if we talk about this actually, the traversing part, like finding out any element. Like if you want to find out that element, in that scenario, array helps us more. In those scenarios, arrays helps us more. So it depends always on the scenarios. If your scenario is, if you want to create a data, if you want to create any data structure which will be using less for fetching data, less for fetching a data, then you will use the linked list on those scenarios. But if you have any database or data structure where you have to insert mostly or update or delete mostly, then in those scenarios, people will have to take the linked list. Linked list will give you better performance compared than arrays. Okay, understood, Vishal? These are the, I will share one screenshot also in that group, which will tell you the difference between arrays and linked list. Okay. Okay, so let's wrap today's call here. Okay, Likhit is saying no about what? Once repeat, append code, little bit confused. Append code. Okay, so in append code, what was happening, Joseph, that append means we have to insert at the last element, correct? We have to insert at the last. See, I'm not sure, like if you want to really understand things, You should not understand the code. If you are trying to understand code, it means you are trying to learn things. You are trying to, like, what do you say, rat rahe ho. In Hindi we say rat rahe hain. You do not need to learn those things. You have to understand with the logic. In the append scenario, we have three elements, right? Tail is right now here, this dot tail is here, correct, and this is pointing to null. If you want to insert a new element, so first you need to make a this connection. You have to make a this connection. And how will you make this connection? You will take like this dot tail in one variable. Let tail is equal to, let temp is equal to this dot tail. Now this temp is also pointing out here. So अब इसके next में इस variable को डाल दो. So temp dot next is equal to this new node. Correct. Now temp dot next is equal to new node. So now this connection has been ready. Now this connection is ready. Now we need to change our this dot tail, because now this tail is the new one. This is the new tail. So now we will update this dot tail is equal to new node. Now this new node is our new tail, this dot tail. Okay, and then it will point out to null. Understood, Joseph? That's what is happening in code also. Yeah, actually that's why I like the linked list, because in linked list everything is visualization only. Without visualization we will not able this. If you do not have visualization, this code is so tough. Really, if you do not have the visualization skills, this code is really tough to learn. You cannot learn this code. You will not sure. Now this line will be confusing only. Why we are assigning new node also? Why we are assigning new node here also? So this is very confusing. So that's why understand the visualization. With the visualization you try to. That's why I like the linked list, because in every problem in the linked list will be solved with visualization only. Okay, so I hope I have like taught you this linked list nicely and explained all the doubts of yours. And I am expecting everyone to do the problem which I explained in the last problem. And I hope you guys have enjoyed it. And in the next class we are going to look for the next part of this, where we will be looking into a little bit complicated, like doubly linked list, where we will have two pointers. In one node we will have 2 pointers, previous and next, right? So in that case, again visualization will be helping. See, in the double linked list, only the visualization. See, linked list is whole on the visualization. Without visualization we cannot think about directly the code. Yes, Nilanjan, definitely. Please watch the recording again. And it's not difficult, Nilanjan. If you have the visualization, it's not difficult at all. And if you do not have visualization, this is toughest topic. This is toughest topic. In double linked list, when we will start double linked list, without visualization, we cannot solve the problems of double linked list. Yes? So, okay. So that's all, guys, from today. I want you guys to practice this. Today you have whole day. Sunday you also have whole day. So please practice it. Okay. And I will, and meanwhile, whatever I will read it, I will share that in the group also. And I will also find out all the problems which we have in the single linked list. Like this is the base, right? There will be some problems like we have to reverse linked list, or we have to find the loop in linked list. These are the problems which we do that. Tomorrow my grandfather's birthday. Oh, happy advance birthday to your grandfather, Dikrit. Yes, sure. I will push the code. So I will follow that, and if oh, Gandhi that was very nice joke. Very nice, very nice. Yes, that's right. Thank you guys. If you guys have enjoyed, I like this is. I was very excited to talk about this session today. Very excited. I am like, if somebody is missing this session, I think that would be lost for them. Yeah. So let's finish this class. And if you guys have any of the doubts and any of the problems, we have already created a group. You guys can share there. And if you guys also have some of the content which you find interesting or easy, easy or interesting, just share it there. I will also happy to watch it. Okay. Okay, guys. So, bye bye. Have a good day, everyone. Bye bye. Thank you. Thank you, everyone.